January is usually like pretty dead, which I might take that time honestly to start working again on making the fun little tutorial videos I do. Those were always kind of a big hit. I just haven't had much time to do it this quarter, or this, I guess, semester kind of, because we were streaming 5 days a week. It's a lot, but it was great. It was a great push. We got monetized on YouTube, which I was happy. I think we're about to hit 30K on TikTok as well. So progress is progress. Okay, let's see what the first question is, and I think it comes from Meltered. So if we go to the queue, actual Discord. Yes, and all your college decisions come in last. Those come in around like March, April, maybe April, I think. But okay, yeah, let's see on the queue. Meltered. This is the most blurry thing I've ever seen. Okay, but I'll try to read it. Mid-March earlier. So the big one that we used to use, the website was called Grad Cafe. At least for grad school. Like figuring out like when people got in and stuff. We'd use the website Grad Cafe. Yeah, this is blurry. Yeah. This reminds me of my eyesight before I got LASIK. Huh? I can't see this. Alright. The mass of 2 grams is attached to the end of a light cord to make a pendulum of 5 meters in length. The mass is raised to an angle of 53 degrees relative to the vertical as shown and released. The speed of the mass at the bottom of the swing is... Oh, this is a great one. This is a classic physics question that comes up. Yeah. Okay. The way to do this is by like conservation of energy. So we got to remember that in physics, there's a bunch of different types of energy, but the main ones we usually deal with is gravitational potential energy, which I read is like UG. That's equal to mgh. A classic indeed. What's up, Justin? And then kinetic energy, which is equal to 1/2 mv squared. The reason why this is a classic question is because it also comes up with a little bit of trig involved. And correct me if I'm wrong. I think 53 degrees, is that one of the special, is that the 3, 4, 5 triangle? I think it is as well. I think it's 53 37, right? Yeah, 53 37 90 is the 3, 4, 5. Which I think this would probably be 3, 4, 5. What's up, Clickbait? Wait, Clickbait. Do you stream? Clickbait, are you streaming? Or did you pull the raid trick of like you can join a stream with a raid? Quite the entrance, dog. Good job. Yeah. Okay. So whenever I see these questions, it's like, where do you call height equal to 0? I think I'm gonna call. Yeah, I think I'm gonna call this height equal to 0. I mean, you can do it either way, but. I mean, his name is Clickbait. Can take a guess whether it's clickbait. Let's call this h equals to 0. I think, right? Actually, let's not do that because I want to show that there's like 2 different types of energies, like where each one has some sort of energy. Ooh, you'll donate 10 per school you get into next year.
That's dope.
Wow, that's about to be a big come up, Laz. You're getting into every school, I swear. Clickbait, wait, do you stream, dude? Am I following you? Wait, what? Clickbait? Bait 414? Where's your stream, dog? Oh, nice. Oh, now I follow you. Sick. What do you do? What are your videos? What do you play? Well, last month you played Pal World, it looks like. And what is that? Nice. All right, Meltered. Yeah. So we're going to do conservation of energy. We have two situations. One situation when this thing is at height equals 0, but is definitely moving at some velocity. Okay. And then another situation when it is up some height here, right? Some height. But its v is equal to 0, right? Because it's being held still. So, I mean, I could call this like situation A. We could call this situation B. It is your question, yeah. So we're going to learn. So, by conservation of energy, at the first part here, let's say in situation A, you have no kinetic energy because the thing is at rest, right? It's just held and then it's released. So, we're going to have that KE. Whoa, what's up, Zev? Thanks for the sub, brother. 1/2 mv squared, but velocity is 0. So, there's no kinetic energy here. Blah, blah, blah. Beautiful. And then mu g is equal to mgh for sure. But we don't know what h is yet. Well, I'll get into like what h is when we get to it. And then for situation B, okay, now the block has like descended downwards. And it has a height of 0. So mu g here is going to be equal to mg times 0. This is going to equal to 0. But it definitely will have kinetic energy. And that's going to be equal to 1/2 mv squared. Okay. So, the key thing here is that total energy here has to equal total energy here. Because there's no friction. There's no external forces doing things that are being weird. Well, I mean, except for gravity, but that's cool. We can take into account gravity. But no one's like actively pushing on my thing. Is this A level? I don't know if it's A level. It might be A level. It kind of seems like A level, no? Also, I need my TikTok chat to work. TikTok. What? Why did we just stop working? There we go. Thank you. Good evening to you, Fanatic. Hardest first year science in your opinion? I think physics is regarded as the hardest one. Do I know anything about computer algebra or algebra expressions as binary trees? I might. You can always try submitting it. I can take a look at it. Maybe like logical algebra? I've been doing a lot with like De Morgan's law and stuff. Okay, so here, lock in Unk. What's up, Shifter? I am Unk status at this point, dude. MGH, because that's the only energy here, has to be equal to 1/2 mv squared. So very cool thing here. Notice how the m's are going to cancel. I don't really need the m's. Goodbye. Those are on both sides. To get the velocity, I do need to know the height. So this is actually a cool little situation that's going to go on. Oh, Psycode can probably help with... Yeah. Exactly. Psycode, yes. So, Fanatic, if you want to submit it, maybe Psycode knows how to do it. And then we can learn together. So here's the cool thing about this pendulum. So if this pendulum has a length of 5, it always has a length of 5 as it's doing this, okay? So, for instance, I know that this distance here is 5, right? This to here is 5. But also that this distance is 5. But if I want to get the height of this, right? I need to kind of figure out what this distance is, right? Well, here, and let's pretend this goes like all the way down to this. Oh, I lost my thing, yeah. Hey, no, come back. There we go. Chemistry. Who's got the chemistry problems? It is an isosceles triangle, right? Right? Because this is also 5. This is 5. Star Prod says, any tips for when I start vectors at school? Like some stuff they teach you? Know your triangles, for sure. Knowing triangles will help you out a ton, Star Prod. Just like knowing special triangles like 3, 4, 5s, which I think this is a 3, 4, 5, by the way. Yes, and also I agree with clickbait. Read the textbook first. Get the head start. Things always are easy the second time around. Okay, so this right here is a triangle. And more importantly, it's a right triangle. Okay? And what we should notice is that if I want to figure out what the height is here, I know the whole thing is 5. So if I can figure out what this is, I can do this minus this, and that'll get me this. So in order to figure out this is a right triangle. This is one of the legs of the triangle. Compared to the 53-degree angle, that's the adjacent. If only, I know, I never take my own advice either. So, since, you know, here, let's kind of like mark this. I want to mark this with a special color. Mark this, not with red, maybe brown. Let's mark it with brown. Let's say that this part here is the adjacent, right? So then, cosine of 53 degrees is equal to the adjacent divided by the hypotenuse. Okay. And the hypotenuse of this triangle, right? That's equal to 5. This is a little bit of trig. It's physics, actually, technically, but you do need to know trig in order to figure out the height of this thing as it's falling down. So it's trig and physics. Yeah, trig and physics. Perfect pair, made for each other. Good, very good, Meltard. Yeah, so the adjacent... this thing here is equal to... oh, we moved it, sorry. Is equal to 5, and then cosine of 53 degrees. Which, I think what that's going to give me is 3. I'm guessing it's going to give me 3. Let's see if it does. I'm pretty sure this is a 3, 4, 5. You could use simple harmonic motion and the equation. That's another way to do it. Yeah, you know it's a pendulum, so it does experience simple harmonic motion. I think they want you to do conservation of energy here, though. But anyways, 5 cosine 53 does basically give you 3. Exactly. Well, if it's not a 3, 4, 5 triangle, then you have to do what I just showed you here with the calculator. You have to do 5 cosine 53. Yes, that's appropriate to write. I think the person smarter than you is going to end up being ChatGPT. Chat's really good at writing code. Oh, yeah. Yes, what's up, Narowski? I still got to get you perms. Are we doing physics? Lady Gaga says we are. Good job. Okay.
Yo.
Good afternoon, morning, Narowski. How's it going, dude?
It's going great. I see the queue is empty.
That means we're gonna go learn some stuff, dude. Please, yeah.
Exactly.
Yeah, let's learn some stuff, dude. I'm down. Put in the thing you want us to go through, and we'll do it. Yes. Okay.
Do you guys? I'm asking the chat if.
Yeah, ask the chat. Ask the chat.
If anyone wants to learn stuff about matrices like linear algebra or functions, like functional equations, which is preferred here.
Okay, so chat, you got to tell us. Do you want Narowski to teach us how to do linear algebra, like matrices stuff, or what was the other? What was the option?
Functions.
Or functions. Functions. Linear algebra or functions. Jeff says functions. Nice, Zenith. I hope your pre-calc final went well. JC says chemistry. That's not an option. Mathematic Fanatic asks if Narowski knows computer algebra. And then Psycho says...
computer algebra. I don't know what that means.
Yeah, exactly. That's what I said. Submit it. Submit a question of it. So I have no clue what computer algebra means.
what I know is cybersecurity. That's all I'm good at with computers.
Ooh, there we go. We got a Romanian hacker, dude.
Yeah.
Nice. What about Voronoi diagrams on the sphere? What the fuck?
Disqualified.
What is that, Jeff? Get out, dude. No. Oh, man. Do I know real analysis? I've been learning it slowly from everybody else who teaches it here. I know people that do know real analysis, so we definitely could do some real analysis. And I feel like Narosky knows real analysis because he says he learned that before calculus.
Yeah.
Yeah, exactly. Okay, let's finish this question real quick. So if this is 3 and this whole thing is 5, that means this height here, the difference between where this is compared to where this is, that's equal to 2. So we're basically done at this point. So this is 2. So then we get that 9.8 times 2 is equal to 1/2 v squared. So you can move the 2 over. So then I get 4 times 9.8 is equal to v squared. And I don't know, if I wanted to be super like mean, I could just call this 10. So say the square root of 40 is equal to v, and the square root of 40 is a little bit more than 6. So, and it's not as high as 7. So I think the answer is going to be D, 6.3. That looks about right. Yeah, square root of 40, probably about 6.3. Okay, nice, cool, good question, Melter. I hope that made sense to you. Between 6 and 7. Oh no, dude, not again, not again. Not again. Zach, I was asking, dude, who won your chess tournament? I apologize. I was there for the beginning of it, and then I got like slammed with another student, and I was like, oh shit, it's already 12. Like I gotta go. But yeah, chess.com tournaments are kind of weird to run because you have to set a time. You can't like hit start. You have to tell the time that it starts, and you have to like hope that everyone gets there before the timing starts. It's kind of a mess. Yes, I will post this in the Discord 100%. So, here, if we go to the website, here in Homework Help, I will post the solution to this question from Meltard. Yeah, I've done a couple chess.com tournaments. They're kind of annoying. You have to really like hound people to be in at the right time, but it's a learning experience. Nice. Saved by Harmonic, Millie. Yeah, we'll see what Millie's is. But Narosky has like infinite questions we can go through. Okay, so this was Meltard. I lost in 6 to 7 moves. I saw the one game you were playing with Descendant Fonts, where like Descendant Fonts was just like burning the time. Because I think like Descendant Fonts said that his mom brought him food. I was watching this game, and you were asking whether it's an intentional trick to just burn your own clock. I was like, I don't think so. Okay, let's see what Millie's got. Ooh. Prove that the sequence is not convergent. Isn't this just the harmonic series? Is there really a proof for this one? I just remember that, like, right, the summation of 1 over n to the p diverges for, what is it? P is, absolute value of p is less than or equal to 1, right? Easy proof. Collect terms 2n at a time. What do you mean by that? Sorry.
So they mean to compare with the series 1 over 2 plus 1 over 2 plus 1, I think. That's what they are asking.
Oh, I see.
So,
I mean, this is just known, right? But I guess there's another proof.
Yeah.
Okay. 1 is greater than or equal to 1 plus 2 plus... Wait, Zach, what are we writing?
1 over 2, 1 over 2.
Okay, 1 plus 1 over 2. Wait, is that right? No, 1 is not greater than 1 over 1 plus 1 over 2.
No. I think he means just.
Oh, 1 over 2 plus 1 over 3, which is greater than or equal to 1 over 4 plus 1 over 5. Yes. Fascinating. Okay. I think 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 is greater than or equal to 1 over 8 times 4, which is equal to 1/2. Uh-huh. Oh, I see what you're saying. I see. Okay, wait. I got this. Okay, sorry. Okay. You're saying...
Yeah.
1 is greater than or equal to 1 over 2 plus 1 over 3, right? Okay. And then that 1/2 is greater than or equal to... Well, actually, no. Wait. Sorry. You're saying that 1 over... Yeah. 1 over 3 plus 1 over 4 plus 1 over... No. This is the one. 1 over 8, 1 over 7, 1 over 6, 1 over 5. I gotta like work backwards. Yes. This is greater than or equal to 4 times 1 over 8, right? Because each one of these is greater than 1/8. And that's greater than or equal to 1/2. I see. Yeah. I see what you're saying. Okay. So, as you keep going further and further, you can add up even more terms that are bigger than the term before it. I see. Easier further on 1/9 through 1/16. Each term is bigger than 1/16, and there are 8 of them. Exactly. Oh, okay, I see. So 1/9 plus 1/10 plus 1/11 plus 1/12 plus... Well, I'm running out of things. 1 over 13 plus 1 over 14 plus 1 over 15. I would just use the proof because God. Yes, okay. This is greater than or equal to 1/16 times 8, right? Which is equal to 1/2. Aha, because 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So, okay. And then what would the next one be? Like 17 to 32, I guess? Yeah, 17 and 32 then, yeah.
Do you mind if I provide a proof?
Yes, please.
That is, less intuitive.
No, I don't mind at all, please.
Do you know the definition of Euler's number?
I know that the limit as n approaches infinity of 1 plus 1 over n to the n is equal to e.
Yep. This is the definition.
Good job.
That's correct, right?
So, what we can say from this is that e is greater than 1 plus 1 over k to the power of k for any k.
E is greater than or equal to 1 plus 1 over k.
Equal.
Well, it's never equal to, I guess. Well, at infinity it is.
At infinity, but
the summation is. I get it. Yeah.
Yeah.
Okay.
This is true.
This is true.
Now, if we take ln of both sides, we can just write 1. 1 is greater than
kln of 1 plus 1 cos. Okay, got you. Okay. So this is equal to 1. ln of e is 1. Love that. Then ln of this to the k means you can just pull the k down out front.
Yep.
Okay, so this is greater than or equal to k ln of 1 plus 1 over k. Yeah?
This is true. If we divide by k, then we have that 1 over k. 1 over k is greater than this ln.
Okay, so 1 over k, geometry genuinely sounds like 1 plus 1 equals 1 over 1 plus 1 over 1. It's true. 1 over k is greater than ln of 1 plus 1 over k. Okay, cool.
ln of 1 plus 1 over k, this is equal to ln of k plus 1 over k. This is true, right? If you just bring the 1 inside the fraction.
You bring the 1 inside the fraction.
Right, instead of writing it as ln of
you want to say ln of 1 plus k over k?
Yeah.
Got you. Got you.
Okay. Now, sum both sides from k equals 1 to n.
Sum both sides from k equals 1 to n?
Yeah.
Okay, cool. Oh, I think I see what's going to happen. Are you going to write this as two different sums?
I'm going to write that as a difference of two logarithms.
Good. So this is going to be the summation from k equals 1 to n of ln of 1 plus k minus ln of k, right?
Yep.
Ah.
And that is telescoping sum.
This is telescoping. Oh, this is fucking dope.
Yeah.
That's dope.
So
very cool.
What we've
Yes.
proven that is that the harmonic series, which I think was denoted by Sn,
Yeah.
is now greater than the natural logarithm of n plus 1.
Yes. N plus 1. Which is, unbounded at n equals infinity.
Exactly. So
Nice.
This is infinite.
Which is infinite. Wow, that's super cool. That's beautiful, dude. Actually, that's really cool. That's really pretty. Nice.
Yeah, this is how I learned it the first time.
It's too funny because I think in the U.S., dude, we just tell them this. we just say this.
Well,
is
this
the answer.
this is a proof. This is a proof from. This is very basic because this is before Euler, right? This is before proving Euler's number through limits. This is, I think, circa 1350, if I'm not wrong.
Oh, damn. So this is like during the Dark Ages, or is this like the Renaissance?
Yeah,
Yeah.
I'm not sure. I think it's before.
Wow. Nice question, Millie. Cool. I hope that makes sense to you, Millie. It was kind of fun. Millie is taking like a real analysis class, I think.
Yeah, so
Lucky.
if she's taking a real analysis class, I think that the second solution should be nicer.
That should be nicer, yeah. Okay, so yeah, just maybe like don't look at this. Yeah, don't look at this. And just
That's
look
the
at
intuitive. That's like the intuitive way to do
this.
it.
This is the hamburgers and freedom cheeseburgers way. So we'll call this like the USA way. And then this is the elegant European way. I'm gonna say like elegant. Okay, nice, good question, Millie. All right, what did we decide, Narosky? What are you gonna do? Are you gonna do linear algebra or functions?
I think linear algebra. I saw
think linear algebra too.
Linear algebra, yeah.
Yeah, linear algebra is fun.
Yeah, let me actually find my question. I forgot to submit it.
All right, go find it.
Yeah. Until I do, maybe like.
Yeah, I'll do another
somebody.
question real quick or something.
Yeah.
Let me see. Okay, this is an ugly integral, so maybe we'll save this one for Narosky real quick. Lucky cat. Oh, lucky cat with the chemistry. Okay, let me show this one real quick. It's not too hard. And then mathematic fanatic. Oh, this is. I need a Python string that turns. Ooh, okay. This is the math challenge, or the computer science challenge. I love that you can see me up here in the top left. That's really cool. Okay, cool. It kind of does actually. Here, let me do the chemistry one real quick, and then Narosky's we're gonna do his. Let's see this, and then I'll get to more in the queue. Build a Voltaic cell with one beaker containing a solution of nickel nitrate, and with a nickel electrode, and a second beaker containing a solution of zinc chloride, ZnCl2, with a zinc electrode. Write the half reactions, the flow of the electrons, a short form notation, and figure out the potential. Okay. Okay, so you have a nickel electrode and a zinc electrode. Do you know about sets? I do know about sets. What is zinc's ionic number? I think it's 2+. Or zinc is what? Zinc. Zinc is, ooh, can be 2 plus or 1 plus. Ooh, well, that's gonna be kind of weird. Wait, but I know, okay. I know in this case, right? If it's zinc chloride, Cl2, Cl is always a -1. And since there's 2 of them, that means this must be a +2. And then, the other one is nickel nitrate, right? And I do believe... Okay, so if there's a 2 here, that means this must have been also a +2 then. Oh, that's actually kind of nice. Right, 'cause I think nitrate... Or maybe not, actually. Sorry, what's... NO3 charge? NO3 is -1. Okay, yeah, so that is a +1. Ooh, let's get rid of all this. There we go. How hard can the questions be? As hard as you want to try. I mean, I will try to answer them. If I can't do them, we'll find someone who can. So, yeah, ask whatever. Okay, let's look at, like, a voltaic cell. Let me get a diagram real quick of a voltaic cell. Voltaic cells. Yeah, I want one of these things. I think this is literally your question. Oh, this is with zinc and copper, though. And then we can talk about the bridge and stuff. Yeah. Yeah, okay. Well, can I get like a blank one? I just want like a blank one. There we go. This is exactly what I want. Oh, here we go. Beautiful. Someone made me the picture. Okay. This is the diagram. And then, okay, so the electrodes, you have a nickel electrode and a zinc electrode, okay? So I'm going to label one of these nickel. I'm going to label one of these zinc, okay? And then this is, has a solution of nickel nitrate. So if we want to write out, like, what's happening there, the nickel nitrate is going to have Ni2+ in it. So when this, like, breaks down into its constituent ions, you're going to get Ni2+ and you're going to get 2 NO3s, 1 minuses. That's how you nickel plate things? Oh, maybe, I don't know. So you have zinc, which is going to be going to zinc 2+, and that has to be +2 electrons. And actually, okay, one of these gets reduced and one of these gets oxidized. How do you know which one does? I think it's the one with the greater potential. Yeah, what I usually remember is it's like anox cat red, right? So the anode is oxidized. The cathode is reduced. Okay, so I think we need to know what the potential, what are these called? Voltaic chart or something. You need a chart for this. There we go. Bingo. This is what I need. Okay, so let's look at our chart here. These are called like the standard potentials. And we gotta look at like zinc. Let's go look at zinc. Well, I see nickel. Okay. There's our nickel. And then where's zinc? Zinc even on this chart? Oh, here's zinc. Okay, cool. Uh-huh. Okay. So this is a stronger oxidizing agent. Okay. Which means oxidizing agents are more likely to be reduced. Which means they're the ones that gain electrons, okay? So this thing is reduced. And then this thing is oxidized. So, yeah. Okay. We're going to get there. Yeah. Well, I do need to do a net ionic for here at some... Well, I need the half reactions. Net ionic is you just get rid of all the spectator ions, basically. Okay. So I know that zinc gets oxidized, which that's losing electrons. So that's this one. That's why zinc goes to zinc 2+. And since that's the oxidized one, that is the anode. JC, we're doing chemistry, dude. You want to help me with this? This is chemistry. The cathode is then reduced. That's the thing that's gaining electrons. So that's this. So that's going to be Ni2 plus 2 electrons is going to get me to nickel solid. Cool. Right? Okay. So if I want to like draw these, right? So the solution here, this is still going to have like Ni2+. This is going to have Zn2+ in it. And then the flow of the electrons. Okay, so electrons always flow from... Electrons flow from low potential to high potential, right? Yeah. So they're going to flow towards the nickel side. Okay. So I think the electrons flow this way. Yeah, love me some oxidation reduction. Redox reactions forever, dude. Right, so the... Yeah, we did get chemistry. Yeah. So... Oh, the electrons on the outside thing. Okay, so this is the voltmeter. Right? So because zinc is at minus 0.76, and then this is at minus 0.26 for standard reduction potentials. This is like voltage. Electrons always flow from low voltage to high voltage. So minus 0.26 is technically higher than minus 0.76. So the electrons are going to flow this way. It's okay. We're gonna do linear algebra with Mirovsky next. Don't worry. Electrons move that way. If I wanted to figure out what that is, I think you do this minus this, right? So delta V is equal to high minus low. And so that's negative 0.26 minus 0.76. And so that equals about 0.5. About 0.5 volts. Okay, so if you wanted to read that, the voltmeter would read 0.5 volts. Cool. So, okay, these are the half reactions. Flow of electrons is from zinc anode to from zinc anode to nickel cathode. Short form rotation. Oh, that's that whatever this stuff is. And then you do something like this and like this. Is it anode first? There we go. Got it. Got it. It is anode first. It's anode material, anode ion. Okay, so the anode material, that's zinc, right? Zinc solid. The ion in aqueous, that's zinc 2+. And then the cathode ion is nickel 2+. And then the cathode is just nickel solid. Nice. And then, right, so that was part C. This is part B. This is part A. And then we already did part D. Part D is half a volt. Okay, nice. Cool question, Lucky Cat. Did that make sense to you? Daddy, double thick legs, just passed my Gen Chem 2 exam. Nice, dude. Cool. Yeah, so some general things here, Lucky Cat, to remember, right? Always remember this. Just anox, cat red. Anodes oxidized, cathodes reduced. You explain it way easier than my teacher. Aw, appreciate that, dude. And then when you're looking here at these voltages, because sometimes people like flip these things, and dude, it's super fucked. Like, don't do it.
Oh shit, not good.
Don't do it. Whichever one is higher up, that is the cathode. Cathode's always the most positive thing. This comes from physics, actually, too, right? Cathodes are positive. anodes are negative. I know these are both negative numbers, but negative 0.26 is more positive than negative 0.76. So once you figure that out, and then you remember like which one's reduced, which one's oxidized, easy to write that. I forget what you're supposed to write for the salt bridge, but what would the salt bridge be again? Ooh. Oh, I guess it's whatever the solution is. Which here they said it was KNO3? Where's the copper in that? I don't know about the salt bridge. But I hope they don't ask you it. Okay, cool. I'm going to post that solution for you, Lucky Cat. So that'll go in our Discord. So make sure, if you're watching us, the website, actualoperasaurs.com, you can put your username, put it in a screenshot. We'll go through it. Click here. You can see the queue. Click here to join our Discord. That's where I post all the solutions. And then also click your streaming schedule to see all the different times we're streaming. So we have another stream tomorrow at 4 o'clock. So make sure to come by for that. That'll be fun. Zach's doing an awesome trivia game. It's the final episode, right? The Tournament of Champions. I am in the Tournament of Champions, by the way. That'll be on Friday. And then it looks like a coding challenge on Saturday. And then we got more streams all next week. Cool. Yeah, you're very welcome. Very welcome. Let me ungroup this one. Lucky Cat. Okay, cool. All right, Narosky, do you have the linear algebra thing you want to go through?
Yeah.
All right, let's fucking do it. I'm down. Here, let me save this over. There you go, Lucky Cat. Okay. All right. What should we do?
I sent it.
Oh, you sent it. Oh, sorry, my bad.
Yeah, it's in the queue.
It's in the queue. Which one's it called? Is it your name on it?
Yeah.
Oh, there you go. Ensky. Cool, got it. Let's do it. Okay. Let's see. Let me see if I can decode this.
Okay.
Because Zach has taught me how to read this language. Fuck. Is this this is not there exists, or is it there exists? I think
No,
this is there exists, right?
This is for all.
Okay, that's it. Okay, so for all n that are natural numbers contained in the set of natural numbers, let a of n equal 2 to the ceiling of the square root of n plus 1?
To the floor.
Sorry, to the floor. I got that wrong. Sorry. This is floor. Right. Yeah, ceiling is this one. Someone actually put another integral in for... Where was it? Not this one. This one. JJM put a floor integral that we're going to have to do later.
Oh.
Okay. So, and sorry, this is to the exponent, though, right?
Yeah, that is to the exponent.
Interesting. Okay. So for all n that are natural, let a sub n equal... Okay, so this would be 2 to... Oh, I see. But the square root of 2 is 1.4, so this would be 2 to the 1. I'm just saying if n equals 1. And I think this would also be 1. This would be 1. No, this would be 2.
Yeah, this is interesting. This is meant to be like try different values question.
Yeah. So let me see. Or you said what is A3? What is A4? Okay. But all right, let me see the proof. Actually, sorry. Yeah. Show that there exists some value k that is a natural number, such that for all n greater than k, an is no longer in. Okay, so something is not invertible if the determinant is 0, right?
Exactly.
Okay, I know that. Yeah. Okay. No, we're still gonna do yours, Fanatic. Just give me a second. Determinant of an is equal to 0. But what is a natural number, liberals? I gotta stop. God made the numbers as natural as he could. Okay. What is A3? What is AN? What about A sub 10? What are their determinants? What happens with AN in general cases? Is there a pattern? Okay. So maybe we should figure out
That are
A3?
all the hints. Yeah.
Should we just figure out A3?
Yeah.
I think it'd be kind of cool. Let's fucking do it. All right. So that's 2. 3 plus 1 is 4. Square root of 4 is 2. So that's 2 to the 4. 2 to the 2. So that's 4.
Yeah.
Okay.
No, just keep it as 2 to the power of something. It's easier.
Okay. Let's do it that way. Okay. So this is 2 to the 2. Square root of 5, still 2. Square root of 6, still 2. Okay. So this is 2 to the 2. 2 to the 2. 2 to the 2. I don't think it hits until we get 2 to the 9th, which is here. 2 to the square root of 9, right?
Yep.
Okay, so this is still 2 to the 2, 2 to the 2, 2 to the 3. And then that's going to keep going until we get to 16, which we don't. Oh, okay, so then that's just 2 to the 3, 2 to the 3, 2 to the 3. Okay.
Yeah, so what is this determinant? What is the determinant of A3?
So, if I were to do that, that would be...
Well, no, don't do it.
Well, if I look at this, this is not 0, right?
Well, yeah, but the point is to look at the lines in the columns. What do you see when you look at the lines in the columns?
I see this, and then I see this and this. So it's like diagonal, maybe?
Close.
Close.
What about column 1 and column 2? What do you see about column 1 and column 2?
Oh, they're the same.
And what happens when we have 2 of the same?
Oh, okay. So they're not linearly independent anymore,
Exactly.
right? Okay.
Yep.
And if they're not linearly independent, does that mean it's invertible? Or it's not invertible?
That means it's exactly invertible. The determinant becomes 0. If you have 2 of the same lines, then the determinant is 0.
Oh, I didn't know that. Okay. So if like column n equals column m, then the determinant's equal to 0?
Yep.
Oh, very cool. Oh man, so yeah, it's already the case. Yeah. Because I think someone else was bringing up, and I thought this is cool. What I'm noticing here, Narosky, right, is that based on what n is, there's like a gap in like how many numbers I need to go up to until I hit the next number. So, right, so between like, right, square root of 4 and square root of 9, right, these are 2 different numbers. I only have like 5 numbers that I can hit, right? But then the next one, square root of 16, now this is like 7 numbers in between, and then we get even crazier. Or maybe we do, right? Square root of 25. So that's like 9 numbers, and now we have all of them, no?
Yep.
Okay, so I can show definitely for anything greater than 4, all of these numbers will be the same. If they're all the same, then the determinant is 100% 0. Okay. All right. But, am I supposed to figure out what is k?
Yeah, you're supposed to figure out what the smallest k is. Well, you're not supposed to figure out. You're supposed to prove that there is a k, right? You're not supposed to actually find it. But if you want to, you can find it.
Okay. What's up, Shaq?
Yep. Yo, what's good, guys?
What's good?
Late.
You are late. It's okay. You're never late, dude. You're exactly on time. Just an hour into
I can't even like do the intro, right?
It's okay. It's okay. You gave a great intro last time.
I'm gonna do the intro all the time. No,
I appreciate it.
How's it going though? What are we learning today?
We're learning about linear algebra. Narosky is teaching us some like super cool like linear algebra tricks.
Yo, one
Tasty.
thing that I find really cool, like sorry for cutting you guys off, right?
It's okay.
One thing I find very cool, right? And I know this is like so out the blue, but bro, I know like for like a lot of you new viewers and stuff, this is like kind of nothing, but I just think it's crazy how like we all started with goal just teaching, and now it's like we have so many different, like we've expanded and branched out so much.
We hit 2,000 on Discord today.
Yeah, I know.
2,000 people.
I saw that, and I
That's
was
pretty
like,
dope.
"That's crazy."
dope.
That's crazy.
Yeah, literally, it's insane, bro.
You were probably here when we had like a couple hundred people in the Discord. Now we have 2K.
I was here when I was here for the first summer camp.
The first summer camp. Yeah. Yeah, that was the first like couple hundred people I got in the Discord.
Yeah, that's when I got Call of Duty Cold War. That was the first thing I got from here.
Fuck yeah. The last Call of Duty that was good.
Yeah, Cold War was nice.
Dope, dude. Yeah, well, I'll do like a big celebration thing because yeah, it was cool. We'll do an end of the year like party where you remember I did like Santa Gold like one of the years where I dressed up in like a gold Santa suit and just like gave out prizes.
Yeah, you should give me a PlayStation.
I'll do it at the end of this year. Yeah, because I want a cool little recap. Because yeah, as you said, we've had like so many different people come through, and it's been awesome to see all the expansion. And I love all you guys. And great, yeah, cool.
Like, there's so many new things getting taught. Well, yeah, you have to go back to teaching. So
let me go back to teaching this up. But I appreciate it, Shaq. We're gonna do it.
All right, guys. I'll catch you in the next stream. Hopefully, I'll make it in time. I give my intro.
Peace.
Have a good one, guys.
Yeah, bro.
Yeah. Dope, dude.
You too, man.
Star Prod says might need to change the channel details for the 1,500 plus students on Discord. Yeah, we do. Yeah, we got like there's a lot. It's 2K now. It's crazy. Anyways, it's awesome. Okay, so let's go back to this. So wait, what was Fanatic saying? So eventually there will be two different numbers in the matrix. No matter where it switches, at least two columns will be the same. Oh, okay. I think I see what they're saying.
Yeah, that's what you're supposed to notice. Yeah. So my question here, like as a helping hand, would be what happens with the square root of n plus 9 minus the square root of n plus 1? Like, what is the difference between?
Ooh, like what's the difference between this and this? Yeah.
Yeah, the exponents. So what happens at infinity? Well, when n is very big, not at infinity.
When n is very big, like what's the difference between these two values, or like?
Yeah. What happens when n is very, very big for these two values?
It's basically 0.
So this goes to 0, actually.
Yes. Yeah. This equals 0.
So then,
limit.
Yeah.
Okay. Oh, I see. So then they're all the same because it's all 2 to the same shit.
So at some point, this becomes the same thing.
Correct. All the exponents become the same.
Yeah.
Yeah. Or k equals 15. Someone said k equals 15. Wait, didn't we just prove that k equals 3 is already like good? No?
K equals 3 works, yeah.
Yeah, so there already exists k is equal to 3. It's already not invertible, right? Because of these two.
We haven't rigorously proved.
Okay, show me the rigorous proof. Yes, I know. This is me where I'm like 1 + 1 = 2, right?
That's dope.
Like we're done, but I know that's not right.
The thing is, it doesn't matter how many k we prove this for, right?
Sure.
We don't show it for like a general case if we just pick numbers.
I need like a recursive relationship or something to show why this is true.
Something like that, yeah, something like that. Or we can just prove 3 cases. That's what I'm going to do, right? That's my solution to this. This is actually my teacher's problem.
Okay.
This was proposed by him at a contest, right?
Oh, I like this.
Many
Okay.
years ago. Yeah. And this is how I thought about it, right? So I went through a sub 3, a sub 4, and a sub 10, and I noticed that for all of these, the determinant is 0.
Yes.
Yeah. Then I noticed that the difference, what I just said right now, the difference between the greatest exponent and the smallest one goes to 0 at some point.
Yeah.
So then, what happens, right? If we notice the form of a sub 3, right? It's 2 to the second up until the 5th element in the middle. On the second row, the second element.
Yes.
Right? That's where the change happens. That's where it becomes
the flip. The flip, yeah.
Yeah. So what would happen if the flip happened exactly at the end? So if we just had a sub r, right? So or how do you want to?
Yeah, no, we can do that. Yeah, let's say so like a sub r. Yeah. And it's equal to what? Like 2 to the. It wouldn't be r. Is it gonna be r minus 1?
Oh, yeah, it would be 2 to the r exactly.
Okay. 2 to the r.
Let's just say it becomes 2 to the r, 2 to the r. and so on until the very end.
Okay. So this is like 2 to the s maybe on the last one, right?
No, 2 to the r plus 1.
R plus 1. Oh, you're right. Yeah, because it goes up by 1. Yes, got you.
It goes up by 1.
Yeah.
This is clearly 0 because we have 2 lines that 2 columns that are equal.
Yeah, these 2 columns.
Yeah. So if the change happens at exactly the last place on the last line, then the determinant is 0.
Yes.
If
it happens in the last column.
Yeah. If it happens,
but if it happens here, then it's also wait. If it happens here, then it's also good, right? Yeah, right. That's also good.
This is what we're getting at, right?
Oh wait, and this shit's also good too. Oh fuck!
Yeah.
Wait, is it just always good? Is it just always good?
Wait a second. If it never happens,
getting excited.
Right? If it never happens, then it's also.
It's also good. Yes. This is also.
If it never
yes.
happens, this is also 0. If 2 to the r plus 1 appears on the first line, let's just say it appears anywhere on the first line.
But then it would happen. Would it have to happen everywhere else as well?
It would also happen everywhere else. That's
okay. So you're saying like so if we had
right here anywhere on the first line, anywhere, then the next 6 should also be 2 to the r plus 1.
Yes.
There is an r that satisfies this. So this determinant is 0.
Yes. This one is 0, and this one is 0.
If it appears for the first time, this is important. If it appears for the first time on the third line of the matrix. Okay. What happens? So if it happens on the third line.
Sorry, the third row. What do you call the third row? Sorry, what's the third line? Third row. Okay.
Third row.
So if it happens here.
There or there or there, anywhere. It doesn't matter.
Yes.
If it happens to appear there for the first time.
Yeah.
What will happen?
So if it happens here for the first time, you still have this one will have to be r plus 1. This one will have to be r plus 1, and now all 3 of these columns are the same.
Yep.
Okay, and so that's also determinant is equal to 0.
Yeah. If it appears anywhere on the third line, what happens? You just picked a case. Now, if it happens in general anywhere on the third line, you can say that row 1 and row 2 are identical to 2 to the r, right? So they will be filled with 2 to the r. So then, again, the determinant is 0.
Yeah.
So the last case is what happens if it appears on the second line.
I see. Okay, so if it happens, let's say like right here.
Yeah, right in the middle.
Well, if it happens right in the middle, well then this clears with this. Yeah. So it's determinant's also 0.
Yeah, but you picked 1. You have to do it for all 3.
Oh, all 3? Okay, cool.
So well, for the first time,
obviously, if it hits the first one, then all 3 of these are the same, right? Yeah. If it hits the second one, the last 2 are the same. And if it only hits the third one, then the first 2 are the same.
Yeah.
Oh, very cool.
So the other way to write this out would be if it appears on the second line, then the third line or the third row would be twice the first row.
Yes.
In any case. So you don't have to do 3 subcases.
I see. Okay.
Yeah. So that's how you would shorten it, but your solution is actually also correct.
Oh, okay.
So this actually works for anything.
Did it work for did it work for n equals 1? I guess it has to. I mean, unless it can somehow shift over like 3 times, then we're screwed.
If it can shift over multiple times, it doesn't work, right?
Okay.
So, but we don't have to show this for like we only have to prove that there exists a k, right?
Yeah, we only have to, I'm just curious.
I think the shift happens at 3 actually. So I didn't try a sub 1 or a sub 2.
I want to try a sub 1. So a sub 1, this is 2 to the 1, right? But then this is 2.
Yeah.
Then this is 2, blah, 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 blah. And then we got to get up to this. This is 3. Watch what happens here, Narowski, though, right?
Yeah.
This one goes to
won't work.
3, and then this goes to 3. Oh, wait,
Yeah,
but this one and this one are still good.
Oh, okay. So, yeah.
So A1 actually works. Is 0 a natural number? I don't think it is, right?
0 is a natural number.
Oh, 0 is a natural number. Okay, what about A0?
Yeah.
So that would be to the 1. That's 1, 1, 1, bum, 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 bum. And then... Wait, the 2 would happen here. Oh, okay, wait a sec.
Wait, no.
This would be 1, 1, right? For all these. This one would be 2, 2, 2, 2. And then... This one would be 3. Aha, but you still have these 2 that are hitting.
Yeah.
Okay. Very cool. So it just works for all n.
Yeah, for all.
Yeah. Nice. That's really cool. The hell you mean we're going to count from 0?
I see everybody outraged. I define
Blasphemy.
The set of natural numbers to include 0 and n star to exclude 0.
Oh, okay. So 0 is not a natural number. N star. Okay.
In n star, but in
Rush-
n it should be.
So someone asked in my chat, can you give me a clear breakdown of how to do RREF for a 4x4 or a 5x5? No, dude, that sucks. Dude, what? I have to do that on my final? God help you, dude, if you have to row reduce a 4x4. That sucks.
By hand?
By hand? Yeah, it's terrible. I can show you how to do it on a calculator. But what? I hope you never have to row reduce. Dude, even like a 3x3 is kind of a pain sometimes.
Yeah.
Whole numbers include 0. Okay, cool. This is a fun problem, Narosky. I like this one. I liked going through all the cases and then showing. It's fun how, like, even if one column hand hits, like, the other 2 will hit. So it's either like these 2 hit or like these 2 hit or like, yeah, that's super dope.
Yeah. This is just an exercise of, like, if you can, like, look at a matrix and find out what happens.
I like it.
Yeah.
I thought it was really cool. Nice. Someone said, my professor made me row reduce a 5x5. Dude, what? No, dude. No, bro. What? No, that's just mean. That's just mean and obscene, dude. Who does that to their students? Oh, TikTok, you keep messing up. Okay, cool. Cool question. Thanks for showing it to Narosky. That was fun. I like that. I learned more things. I like learning more things. Okay. Let me get another question up, because, by the way, when 2 rows are similar, it's determinant 0, not columns. Oh, is it rows, not columns? Ooh, we have someone. Psycho in the chat says it's only when the rows are 0.
Says, also. Right, so he means also. Yeah.
Oh, also.
True.
Oh, also. Thank you, Psycho.
Yeah.
Thank you. That's cool. Dude, yeah, a 5x5 is nuts, dude. What? She sucks. I need this, please. I mean, I can show you the general pattern for a 5x5 real quick. One sec. I need my TikTok chat to work. I need this to work. Why won't TikTok just give me RTMP access, please? It'd be so much nicer. Let's refresh it. Come on. Yeah, okay. Well, in general, when you're doing RREF, you want to do what's called, like, the snake method. So here. 4x4 matrix. Let's just get like a... Yeah, whatever. This looks pretty appropriate, right? Yeah. I just don't want to draw all this out. It'll just take forever. And then 4x4 identity matrix. There we go. Perfect. Okay, so just in general, this is called Gauss-Jordan elimination, I think, is what it's called. Because your goal is to try to, like, turn this into this, right? The general strat... Wait, did this just die? What? One sec. My YouTube chat just died. There's TikTok. 5x5 determinants have 120 products. That's obscene, dude. I don't want that. Wait, why is none of this working? What the hell? Okay, one sec. I gotta fix all my chat things. Tell them what the form is called. Row reduced. You tell them what the form is called. Row reduced echelon form. Yes. Okay, one sec. There we go. All right. I need this to work. Activate source. Connect. Okay, there's all my chats coming in. Wow. Okay, that'll fix finally. Okay, there we go. Now we're back. Okay. Okay, so the way to do this, Rashawn, is you want to start up here, and you want to like snake. You want to do this. Okay? And then your goal is to try to turn each one of these things into what this is. Okay? So you try to make this thing a 1 first, and then you try to make all these zeros. And then you come here and you try to make this 0. And then you try to make this 0. But then you try to make this 1. And then you try to make this 0. And then you try to make this 0. Try to make this 0. Try to make this 1. 0. 1, 0, 0, 0. That's, I think, the safest way to do it, like, in terms of a process, because then you don't end up, like, screwing up cells that you already worked on. That's what I've learned for doing RREF. I believe this is called Gauss-Jordan elimination. Right? Yeah. You can probably see how they do it here. Also, wait a minute. What is my chat set to? Rashawn says, but what if there's no general solution to a system? I can't seem to recognize it. Well, so that's if any of the rows and the columns are the same then. Right? Oh, yeah. Joseph says, can you explain what a matrix actually is and why matrices are useful? Yeah, they're great for handling large data sets, but in like middle school, high school, they're useful because you can write out systems of equations. So, fake Joseph. How do you submit a question? The website, actualofficehours.com. So, yeah, so look, for instance, in this one. I think usually what they try to go... You see how he's trying to turn this thing into a 1 first? He does that, right? And then he turns this into a 0. And then this is already a 0, which is great. So then his next goal should be to turn this into 0. I guess he doesn't. He comes up here and turns this one. Wait, where is he going with this? Oh, I guess because this is easy to just make this 1 at this point. This is for the inverse. Yes. Which is, you're also doing like RREF, but you're also maintaining another matrix next to it. And you're doing the same row operations on that one as well. Nice. Good job on your finals, Marissa. Yeah. Lucas says, Ramajan... I don't know what Ramajan sum is. I can never find a pattern for pick... Okay, so in general, just do this. This is the pattern. Do this. You'll be pretty safe with this. Just do this. Okay? Cool. All right, let me see. Other questions. This? Do I know how to do floor integrals?
I could help.
Okay. What do you think, Narowski?
Floor.
Yeah.
So I'm not so good at integrating, right? But I'm good at floor functions, and what I know is that the floor of 1 over x is constant if we are in the interval n plus 1, I believe.
Thank you, Marissa. Let's see. 1 over x is constant. Floor of 1 over x is constant.
Yeah, if and only, I think we can say if and only if.
If, okay. If and only if.
Yep. 1 over x is in the interval n plus 1.
Okay.
I think including n. So on the integral here is constant, I think, or integrand.
Oh, I see.
Yeah. So it's constant 7 to the n.
7 to the... Wait, where's the n coming from? Sorry.
Well, from the bounds on...
Oh, it's integrating from 0 to 1. Oh, you gotta let...
Yeah.
Mathematics, you gotta let u equal 1 over x. Okay. Let me think about this. If
you take the bounds...
Yes.
Yeah, I think I understand if you take the bounds from our 1 over x condition...
Mm-hmm.
And include them as bounds on the integral, does that work?
So you mean
like
if I integrated this from n to n plus 1?
Actually from n to n plus 1 of 1 over x.
And then, well, okay, so this is now the new u. So if 1 over x is equal to u, negative 1 over x squared equals du, or negative 1 over x squared dx is equal to du. Does that really help me though? This is a series of integrals. 0 to 1/2 is one integral. 1/2 to 1/3 is another. Oh. This is actually cute. I see how this works. Okay. So, if we were thinking about this as like a function, right? 1 over 7 to the like whatever the fuck, right? I don't know what this is gonna look like. Probably something like this or something. Well, let me think. That goes to 1/7. Oh no. So it looks something like this. You have to break it up into intervals where this is a number. So for instance, because it's a floor function. Yeah, because this is based on what x is. Oh, okay. Right. So when x is 0, what is the floor of 1 over 0 though? So what's the floor of infinity? Is it just still infinity?
That's infinity, I think.
Okay. But the value of that function is 0. Oh, okay, wait. Calc 2 is integrals, Calc 1 is derivatives. If you do substitution, it becomes much easier. All right, let's just do it. All right, because the 1 over x I think is bugging me. So you're saying like 1 over x is equal to u? Is what we want to sub? So then this is the integral from... So x equals 1 over u. So wait, x then goes from 1 to infinity, no? Or infinity to 1. It actually goes backwards, right? Right, Fanatic? So this is the integral from infinity to 1 of 7 to the floor. So 1 over 7 to the floor of u. But then what does dx become? So dx becomes negative 1 over u squared du? Yeah, okay. I don't think there's a u squared on top, though. If I look at this, right? So this is the same thing as saying u is equal to 1 over x. So then du is equal to negative 1 over x squared dx, right? But I don't really want that. Because I want it in terms of u. Yeah. Yeah, x equals 1 over u. So then dx is equal to negative 1 over u squared du. Okay.
What is the point? What is the point of the substitution?
This is just easier to look at than like I keep trying to think like if x is 1/2, 1 over 1/2 is 2. It's easier.
You don't need a substitution to do that.
Yeah.
Sorry. Yeah, you don't need a substitution to like change the if the exponent was giving you troubles, like you didn't need to substitute for it.
It was making my head hurt, I think. But mathematic fanatic. Yeah. Well, let's see. Does this make sense with floor then? Wait, how does this break up then? How do you do this integral?
I was gonna suggest like why not keep it as x, but then flip the 1 over x.
Okay.
Like I'm not sure how to say this. This is like my English is fighting with me right now. Okay, so we have an inequality in x, right? Like we don't really care. Yeah, like yes. I'm looking at that, and it's I'm just thinking, what if we just solve for x, like flip the raise to the power of -1.
Okay.
That whole inequality, raise it to the power of -1.
Sure. So what? That's 1 over n is less than or equal to x, which is less than.
To be greater.
Oh, but okay, it's gonna flip though, right?
Yeah.
And then this is gonna be x, and then this is gonna be 1 over n plus 1.
Yeah.
Okay.
So now the value of floor of 1 over x.
Yes.
Right? Would be n. No?
Mm-hmm. Times 1 to infinity.
I think the way the mathematic fanatic was saying it, I think that works too, but I don't see the reason of doing a substitution if he can just not make a substitution.
Yeah, no, I see. This question's making my head hurt. Okay, I'm gonna pass on this one because my head hurts, and I have 10 other questions to go through. But so, if someone else wants to write this up, please.
I'll do my best. I'll try.
Thank you, JJM, for making my head hurt. It's okay. It happens. Okay. I see what you're saying, mathematic fanatic. Yeah, I get it. Because then it's 1 to infinity integral from what's up, Jack? Y'all hit me with the hard ones today. Yeah, for me, I can only get a grip when it's floor n and not floor of 1 over n. I think I'm kind of with you, Fanatic, on that. The 1 over n is like hurting me. It's making everything go back. And then it's 1 divided by that. Which is even more weird. Okay. All right. Let's see what we got. Jack Brown. Yeah, are you Jack from Alabama? Jack from Alabama? Oh, you think you do? Okay. If you want to finish it, it's in the Discord. I'll mark it as like unsolved. Someone wants to go after it. Okay, let's see. This one. Oh, this one's from you, actually. What's up, Sam? Thanks for the resub. I need a Python function that turns a LaTeX string into a JSON tree like this. What's up, Jack? Thank you. Jack, what grade are you in now, dude? I remember playing Fortnite with you when you were like 5th grade or something. 6th. A plus 3 is add A and 3. B minus B is sub B minus B. Oh, okay. A JSON is just like a bunch of nested like matrices or something, basically, or nested arrays. Sorry, I guess. Sorry. So x squared minus 4x. Wait, does it have to do order of operations though too? Oh wow. Ninth grade. Nice, dude. Welcome to high school. You're 15. Cool. Congrats. It has to encode the order into the tree structure. Oh, okay. Psycode says this is depth first traversal. Oh, it's okay. Whenever you find a node and open bracket, you're going to go down one level. Okay. I see.
So you're like, oh, division, yeah, baby voice. And then you have to go down. Oh, fuck, I'm messing this up. She actually make me hydrate all fucking night, dude. Thank you. I need this to accept latex input into my algebra and... Oh, yes. Yeah, Mathematics Fanatic is working on like a Manum type animation thing. Oh, this is awesome. I get what you're trying to... I get why you're trying to do this. It's you have different animations for like divide, add...
and stuff. And then, I get it. You want it to do these different things. Oh, very cool. Add a plus 3 sub b minus b sub, and then it drops. Oh, and then this would be mult, right? This would be multiply. And then this would be 4 and x, right? Psycho says, so what you want is called sub-expression recursion parsing, and it's something that happens in every programming language. It's not hard, but it's not trivial. Have you tried asking AI for it? It's pretty good sometimes. I'm just curious. Let's see if here. I need a way to do this in code. Just curious. Am I insane for failing the same thing 6 times now? No, it's okay. Maybe get some help if it's not making sense to you. Okay, apparently this works. Wow, it just like keeps going. Is there not a nice standard library solution? Yeah. Psycho said, yeah, this is... Yeah. So, I mean, like anything, you can just rewrite this into, like, some sort of class, right? And then just call it as many times as you need to later. But yeah, it's definitely not trivial. Looks pretty cool, though. Okay, cool. Here, I'll share the code here with you. AI is like pretty good at figuring out code because it's basically built on code. And it's good at figuring out algorithms. At least the brute force way of them. Yeah. Oh, thank you, Newvin. Thanks for the sub. Okay. People should not be rewriting these all the time. I know, but that's why we have libraries. So here, you could write the library and you could be the first. Yeah. Okay, let's see what else we got. Star Prod, what do you got for me? Curvature sketching. Yeah. Daniel. Which Daniel is this? So, baby? Okay, here, let's do this question. A container with an opening is filled with nitrogen N2. After 240 minutes, it observed that the pressure inside the container has decreased by 10%. If the same container is filled with helium, how long will it take the pressure to decrease by the same percentage? Ooh, I like this. Okay. Yes, no, I agree. Sometimes you just gotta brute force it, Fanatic, dude. I've had good luck with AI with Python, but SAS? What's SAS? Is that like a statistics language, like SPSS? Alright, PV equals nRT, and then the other one we need... Oh man, what's this called? The effusion law? Fusion rate law? Yes, except one of these... Dude, one of these screenshots is wrong. I remember this. Yeah. It's this one, dude. The first... Dude, this is horrible. The first Google image result for Graham's law of effusion is incorrect. The thumbnail is wrong. Yeah, it should be this. No, dude, it's hilarious. If you go watch this YouTube video, dude, the first comment is like, yo, fix your fucking thumbnail, dude. Where is it? Here we go. Actually, the formula of the thumbnail is not correct. Yeah, exactly. Like, please fix this. Yeah, everyone's like, please fix the thumbnail, dude. Okay, anyways. Yeah, this is the law of effusion, right? Which says that the rate at which gas escapes through any sort of hole is inversely proportional to the square root of their masses. Okay. And then rate, right, is... This is, blah, blah, blah. This is like dn dt. Or like d little n dt, I guess. Where this is like the number of moles. Yeah? And then PV is equal to nRT. So, assuming, right, the volume is the same. The R is a constant, T is the same. Then pressure is directly proportional to the number of moles in there. Okay, so if the pressure decreases by 10%, the number of moles had to also decrease by 10%. Right? I think that's how we say this. Yeah, okay. So it's just P over N equals P over N? Well, here. I think the 10% is actually, I don't think we really care about the 10%. I don't think we care. Because this tells me right now that the amount of moles of gas in there is directly linearly proportional to the pressure. So I actually don't care about the 10% because I know it decreases by 10% on each one. The time I do care about, right? So if something has half the rate, it's going to take twice the time for it to decrease the same 10%. So I think we just have to compare the rates. So what is it? Helium versus what? Helium versus nitrogen. N2 I think is 28 28 grams. Yeah, N is 14, so 28. Effusion, yes. Yeah, so that one's inversely proportional, so I'll show you. Helium mass is 2. Okay. So, here we go. So, let's say 1 is the nitrogen. So, rate N2 over rate HE is equal to the square root of 2 over 28. Right? So that tells me that... Oh, okay, so then rate HE is equal to the square root of 14 rate N2. Just had my chem final, now I see this. Yeah, dude, the algorithm... Dude, TikTok is scary good at reading my live transcript, and it knows when we're going over chemistry to go show this live stream to chemistry people. There you go. Okay. If you submit a question about transformers in E&M, I'll do it. Okay. So helium has a rate of effusion that's square root of 14 times more than the rate of the nitrogen. Okay. So what is that as a factor? So here, square root of 14 is 3.74 times. I don't know about three-phase motors. That's a lot. Oh, you were asking about the plug question, earlier? I haven't gotten back to it yet. We were very close in that one, weren't we? I think it was just a parameterization issue, no? Rate HE is equal to 3.74 times rate N, okay? And then, right, so, rate equals amount over time, right? And since the amount that is decreasing is the same, right, the 10%, rate is inversely proportional to time. So, the time for HE will be equal to the time for N2 divided by 3.74. Or the other way to kind of see this, right? Here, if you want to write this way. So here, so rate HE is equal to A over THE, and then rate N2 is equal to the amount over TN2. Okay? If you divide these two, right? You get rate HE over rate N2 is equal to time N2 over time HE. The Jacobian look too much? Yeah, it did look kind of like a mess. But I wrote out what it was. Like chat at least did the Jacobian for us. Okay, and HE to N2 is 3.74. So 3.74 is equal to time N2, which is 240 minutes, over time HE. Okay, so it's just 240 divided by 3.74. There you go. So it should be 64 minutes. Would I ever cover chaos theory? Probably not. That's a little crazy. A little chaotic. Okay, 64.1 minutes. I think. Does that make sense, Star Prod? You can kind of think about it this way, right? Yeah. Yes, cool. Yeah, you're very welcome. Nice. Chemistry. We love chem. All right, Star. I'll post that solution in our Discord. Make sure if you're watching, the website to submit questions is here, actualofficehours.com. Drop your username, put in your screenshot. You can see the queue of the questions we're going through. Queue's actually not getting that long. And then join our Discord here to see all the answers that we post as we get through them.
I did actually manage to solve that guy's integral.
You did? Did
Yeah.
you post? Did you post a solution for it?
Yeah.
Let me see.
It was indeed like two infinite sums.
Okay, let's see. Let's go look at this one. You do get coins for questions. Your book says 90 minutes. Really? Let's see why that is. Also, yeah, Star. Is your name Star in my Discord? Is it just Star? I'm assuming it's Star. All right, let me check real quick. One sec. This is Narowski's solution to this one. I want to see this for a second. Okay, and then before I do that, let me check real quick what we got wrong here. Oh, HE is 4. Yes, Star. My bad. I thought HE was 2. Wait, the mass of hydrogen is 1, no? It's alright, yeah, okay. Yeah, right. Helium mass is 4. I don't know why I wrote 2. Hydrogen mass is 1. Yes, hydrogen mass is 1. I thought helium was 2 because it's like, oh, H and then HE is just another. But HE also adds in the neutrons. That's why. Got you.
Yep.
Okay. I forgot.
If it was 2, it would be deuterium.
What's U?
Which is...
U is the atomic units. AMUs. So yeah, sorry. This should have been... Let me fix that real quick. I'm going to be upset if I don't fix that. Square root of 7. What was the square root of 7?
Like 2 something. 2.6.
Yeah, right. you got that exactly, dude. Narowski. Yeah, it's 2.6. Okay. 2.6. And does that make sense with 90? It does, right? 2.6 times 90. That's 180. Yeah, okay. Yeah. There you go.
Perfect.
What are you gonna for Christmas break? What am I gonna what? What am I gonna do? Probably like relax. A little bit. Yes. Y says, I'm doing my PhD on quantum dots and characterizing them using machine learning. It's too difficult. It's okay. Believe me, a lot of times during my PhD, I thought things were way too difficult and I wasn't going to finish. But then I did. So, hang in there, dude. Like, Isabel says, I was halfway through that integral to the one that just got solved. I also got 2 sums, but I got stuck towards the end of the simplification. All right, let's see. We'll see what Narowski got. So x is defined from 0 to 1. So 1 over x is defined from 1 to infinity. So for all x between 1 over n plus 1 and 1 over n is a natural number, which implies that 1 over x is in between n and n plus 1. So 1 over x is equal to n. So 7 to the 1 over x is equal to 7 to the n. You're very welcome, Star. Oh, am I going to get any gifts from my family? I don't know. I'm getting a little old for gifts. Okay, so then you rewrite this as the sum. Oh, so this is a sum of integrals.
Yeah, that's because it's not continuous.
You're right. It's not continuous. N equals 1 to infinity from 1 over n plus 1 to 1 over n of 7 to the n dx. Okay. Which... Oh, but there's no x in here anymore. Okay.
Yeah,
so
there's no x.
There's no fucking x anymore. Okay, so it's just this.
That was the point. That's what I was trying to do, so you don't have to integrate anymore.
Yeah, like no more x's. That's actually really cool. Okay. Yeah, because the integral of dx is just x.
Yeah.
And now this is just a geometric series or something, right?
Yeah, something like that.
Yeah, okay. So 1 over 7 to the n. 1 over 7 to the n plus 1. Interesting. S1. 1/7 to the n over n. Wow, you know this one for negative ln. Wow. Okay, yeah. This one is negative ln of 1 minus x. Okay. So this is ln of 7/6. And then S2
You just
was...
pull out a 7.
Oh, you pulled out the n equals 1 solution, I guess, right?
Yeah. And it's just 7 to the n times n now.
Uh-huh.
Yeah. And you bring it back. I just did that to make it simpler.
Got you. Oh, so it's the same thing then. Oh, very cool.
Yeah.
So then it's, 1 minus 6 S1, but then S1 was ln of 7 over 6. Wow, very cool. You're getting a lot of praise in the chat, dude. Everyone says, "Oh, nice work, good job, Moroski." That's super cool. Yeah, there's no way I would have gotten that. But again, this is the benefit of having a community, is because I can do like the physics and chemistry and stuff, but some of this high level math stuff boggles my mind, and like you can see, I'm just like floundering here. But when I see a nice clean solution like this, oh, that's pretty. Also, I don't think I would have remembered this. And also, I think the hardest thing I was having, Narowski, was like trying to understand going from this to this.
Yeah, that's a big part of it. Yeah.
It's the big jump. Big jump. N equals 1 to infinity. I see. So that's how you discretize a continuous integral, is you just put a sum in front of it, and then you have the bounds be like part of the sum. Oh, that's cool, man.
Yeah.
Mathematic Fanatics.
Either you write it as that, or just multiple integrals, right? Like you put in values for fraction.
But aren't there an infinite number of fractions it goes to?
Well, yeah, but you can take like the first few and put them in the calculator and see what values they bring out. So.
Oh, okay. Got you. ChatGPT is giving up. At some point, it's gonna be 0. I see.
Yeah.
I think this is way more elegant, though. I really like this. This is really cool, actually. This is super cool. Yeah. These floor and ceiling... I've only seen these floor and ceiling functions, like, this year. I think as I've been streaming more on YouTube and getting, like, the YouTube math warriors, I've started getting some, like, pretty extreme questions.
It's nasty because we have, like, it's mandatory to do floor and ceiling in 9th grade here.
Oh, really?
Nasty.
No, dude,
Yeah,
I never saw that even in college. Real says, why was 6 afraid of 7? Sine 21? Sin 21? Wait, I feel like there's multiple memes here. Why is there not like an e to the 69 too?
Nice.
Okay. Alright, Dan, what do you got for me? Ooh. Here's some chemistry. Where's my chemistry friends?
Yeah, like, I can do integrals, but if you make me do this, like, I'm not gonna be able to do anything.
Yeah. I got you. So, intermolecular forces. So all of them have London dispersion. That's for sure. Which I think is also called, like, van der Waals forces. This one specifically has hydrogen bonding. Because it has an oxygen and a hydrogen, like, chilling out here on the edge. So B does not. B does definitely not, doesn't have hydrogen bonding. I want to say that A doesn't either, because I feel like the oxygen is trapped. And, like, you can't really bond to it. Sorry, what are all the intermolecular forces again? Thank you, Horror Cult. Intermolecular. There's London, hydrogen. Oh, dipole. Oh, there's a bunch of these. Ion-induced dipole. Okay. Right. Dipole is when you have something that is polar. Which... Yes. A doesn't have a dipole, right? This doesn't have a dipole. This does, right? This has dipole on it, yeah? Dipole just means that there's a lack of symmetry. There's no symmetry here. Ethers are aprotic. So, yeah. Ooh, interesting. Aprotic means, they're not proton donators, so, like, they're not acidic or something? Thank you, No Grav, dude. Y'all are just sending me tons of jewels in the chat. I love this. Like, I don't even know what these things are for, but thank you. They don't hydrogen bond. Cool. Okay, so do we agree with this, F32? So far?
Why does A not have dipole?
So A doesn't have dipole. First, because this is symmetric. So in order for something to have dipole, you need to have some irregularity in what the molecules are, because they have different polarizations or different, like, they pull electrons in different ways. So, for instance, I think oxygen will pull more of the electrons away from carbon, but because it's pulling more away from here and pulling more away from here, that effect balances itself out. And so there isn't a dipole moment. In the case of oh, thank you, Horacol. Appreciate that, dude. No, I'll take all the jewels. Appreciate all you guys. And yes, not many people here are actually teaching people. Yeah, I mean, a lot of people just like to post thirst traps and stuff, but I don't know. I don't have the prettiest feet or something. This is non-polar, again, also because everything is like homogeneous and there's like symmetry. This is polar because this stuff has like an oxygen over here and this doesn't.
Yeah, but isn't the bond between carbon and oxygen in the first one, isn't that polar?
It is a polar bond, but I feel like there's another polar bond here that cancels it out. Or maybe F32 says nothing cancels it out. Yeah, but isn't it getting pulled in the same direction by two things? Like, well, the difference for this is, right, so H2O, right? So oxygen looks like this. Wait, what am I drawing? Sorry. Oxygen. This is H2O. Okay. This is definitely a polar molecule. Because I think they write it like this. This is bent because of these lone pairs. And so that causes it to have a net dipole moment in this direction. Nate says he thinks they cancel. Yeah, the question, I guess, is whether this is straight across or whether it's like this, I guess. And then, yes, then there's a net dipole moment this way. So we have two opinions. So here's what I'm going to do. I'm going to ask chat. I'm going to say, like, what is this molecule? And then I'm going to ask whether it's polar. Dimethyl ether. Cool. I'm going to say, is it polar? Says it is polar. The CO bonds are polar. Yes. And it has a bent geometry, similar to water, but less bent. So they do not cancel.
That's dope.
Okay. So, yeah. So, yeah. If this was flat like this, then this would be nonpolar. But because it's bent, it's similar to water, where even though they're the same, they're not at the nice angle. Yeah, okay, so whatever. This is also polar. You're right, F32.
Oh, yeah.
But I appreciate the discussion. Okay, so this is polar, which is dipole. Okay. So, but I'm pretty sure this is nonpolar. Okay, there we go. Based on the intermolecular forces, rank them according to their boiling points. So, hydrogen has the highest boiling point. So that means compound C, right?
C, yeah.
And then which one has the lowest one, Narosky?
Lowest, B?
B? Yeah, very good. And then the middle
Nice.
one must be A.
It must be,
AC.
yeah.
Nice. Yes. Nice. Okay, cool. Great question, Dan. I appreciate that. We love chemistry. I have so many friends who want me to do more chemistry. Awesome. All right, have you taken chemistry, Naroski?
Yeah. It's every science is mandatory.
And you're in like 11th grade, I think, right? 11th?
Yeah. 11.
So,
I
when
should
I was
know a lot more. It's just I should know a lot
You're
more.
just like, I don't give a shit about this.
Yeah.
Bro, I was the same with like biology. I'm like, bro, why are we just memorizing all this shit? Like, yeah, I get it. The mitochondria is the powerhouse of the cell. Like, duh. I like chem. Chem has math. It doesn't have the most math, but it's got way more math than biology. Yes, that's correct. Naroski is in 11th grade. Yeah, he's a super genius.
Yeah, I am. I'm not a
No,
super
no one,
genius.
no one thinks you're in 11th grade, dude. They're gonna make me like. You're gonna have to do like a face reveal with like your passport or something. Okay. Chem is cool. Ooh, what do we got here?
Oh, I did this already.
Yeah, this is not a hard integral, is it?
Yeah, this is simple.
This is simple. Let me get the easy win. I want an easy win here. Okay, let me explain to people. So, square root of x is the same thing as x to the 1/2. So, 1 over the square root of x is the same thing as x to the minus 1/2. Important to remember our exponent rules. Yep. It's okay, star prod. I'm 35, and like I don't know half this shit either. Okay, so this I can rewrite as 6x to the negative 1/2. And then I can write this as two separate integrals. We're going to say dx plus the integral of 6x to the positive 1/2 dx. And then the cool thing, this is just a simple power rule, is you take this power, you raise it by 1, and then you divide by the new power. So this is going to go up to positive 1/2, and then we're going to divide by 1/2. Dividing by 1/2 is multiplying by 2. So I'm going to get 12x to the 1/2 plus this integral, which this is now going to go up to the 3/2, and then we're going to divide by 3/2, which is multiplying by 2/3. So this is going to be 6 times 2/3. So actually, I should let me write this one. Sorry, 6 times 2 over 1. So that's 12x to the 1/2. And this was 6 times 2 over 3. X to 3/2. So that's 4. And then if you want to write it... Oh, and then also don't forget plus C. So if I want to write this out, this would be 12 square root of x plus 4 square root of x cubed. I think it's right. Plus C. Nice. Okay, cool. That was a fun one. Love that one. Okay, nice. That was Bagel. Bagel Brook. Where did I put it? Where did I put it, Bagel? Yes. Okay. Next one. Who we got? Ooh. Complex motion of a point. Dynamics of relative motion. Ooh. Okay. This has been translated. Appreciate the translation. Okay. A thin circular tube of radius r rests on a vertical plate and rotates with constant angular velocity about the vertical axis as shown. Inside the tube is a small ball of mass m which can move with respect to the tube without resistance. Determine the equation of the relative motion of the ball in the tube. What are the equilibrium positions of the ball at angular velocity? That and that. Assume if... Yeah, what's up, Pen? What's up, Pen? Shout out. Pen Center's great. Oh yeah, where'd my clock go? Oh, you know why the clock? No, the clock's still there. It's because it's in the white mark because the sub goal is down. If someone follows, it'll go back. The clock's still there, right? You see the clock? Yeah. Okay. What's up, AFG? This is a cool question. It's like if you have like a bead. Hope you're doing good, Gold. I think David and I are gonna get tofu KFC chicken tonight. Do they like, is it KFC but with tofu? That's kind of fun. BK says I got a 94 on my calc final. Calc 3 final. Dope, dude. Good job, BK. Great job. I remember you were about to take that exam. 94, that's solid, dude. Yeah, we have a couple places like that in LA. Okay. I know this problem. I've seen it so many times. I just forget how to do it. But basically, like, if you have a bead here, and then you start, like, spinning this around, the bead, like, starts to move upwards because you have a couple forces on it, right? So, as this thing is spinning around this way, right, there's an acceleration that needs to happen inwards, right? There's some AC, which needs to equal to V squared over R, which is R omega. Wait, yeah, it's R omega squared in terms of angular stuff, right? Because V equals R omega, so V squared is R squared, omega squared over R is R omega squared. If there's no friction, the ball doesn't move. Oh, the ball definitely moves. If there was no friction, wait. If there was friction, then the ball wouldn't move. No. It can move inside the tube. You got to think about what the forces are on this, right? So there's going to be a force of gravity, right, pulling down, and then you need there to be, I think, a normal force from the tube on the ball, right? Yeah, because then it's spinning around this way, I think. Yeah, it's spinning this way, yeah? Okay. No, you're not dumb. It's okay. Okay. And then when it's at equilibrium, so if I just left the bead here, it would just fall down. Right? Because gravity would push it down. Equilibrium position would be here. But if it's spinning, now it needs to have a centripetal acceleration towards... This is the interesting part. The centripetal acceleration, the R for that is not R to the center of the circle. It's R to the axis of rotation. Oh, I remember. So there's there's some angle shit we gotta deal with here. But the normal force always points towards the center of the circle. The center of the hoop. Because that's normal to the surface. Okay. I think we define like an angle here is what we do. Yeah, definitely. Yeah, submit. I love optimization problems. Please give me one. Okay. Okay, let me relate these angles, right? Let me call this like some angle theta, right? So then, and then let's call this like R perp to the rotation. So R perp is equal to R sine theta, right? Oh, and this is how we're going to get the position. I got it. Right. And then the normal force. Yes. The normal force have two components. So you have FNY, which is going to be equal to Fn cosine theta, right? If this is the normal force pointing directly this way, the amount that points up is Fn cosine theta. Our perp, yeah. Fn x is equal to Fn, and this is a weird case where like the x component is actually sine, because you got to be careful. It depends like which angle you're talking about. I wanted to talk about this angle as being like theta, because then I'll be able to get the height of the thing. This is going back to, dude, I love how everything's connected, dude. Everything's connected. This is going back to this question. Remember when we had this, when we had the pendulum? And we wanted to know how high up it was, right? And then we were like, oh, find this angle, find this, and it's this minus this. No, I like related rates. Those are all great. It's fine. Okay, here we go. Oh, this is super dope. Okay, I think I got this. Okay, in equilibrium, I need Fny, so the normal force that points in the y direction needs to cancel out the force of gravity. So this must equal to mg. And then this needs to be responsible for my centripetal acceleration. So this needs to equal to m. And I'm not gonna do v squared. I'm gonna do it in terms of this. I'm gonna say m r perp omega squared, because AC is equal to r omega squared. This is r perp omega squared. Let's make this theta. Oh, this is so cool. I think I actually like this question. And then, right, they gave us some omegas. I don't know why they gave us omega and lambda. It's kind of weird. What the clock is? What do you mean what the clock is? What the clock on the stream is? The clock on the stream is how much time's left in the stream. Okay. No quantum mechanics yet. Okay. So, I think I have everything, right? Do I have the mass? Do I care about the mass? Actually, I don't think I care about the mass. Well, yeah, wait. Okay, so from this, yeah, stick around. Don't worry. I will get through. I will get through the questions. We have 45 minutes. Also, make sure if you're watching, and we don't get to your question or you got to bounce, make sure you go to the website that you submitted the screenshot and join our Discord, because every single question that gets submitted on this live stream will get put into the Discord. I don't think there is a way with conservation of energy. Maybe if you wrote like a Lagrangian and then like tried to minimize it. Yeah. Yeah, I don't think you have the mass though. Okay. So anyways, Fn is equal to mg over cosine theta. Right? So then if I take this and I plug it into here, that gets me mg over cosine theta sine theta is equal to m r perp omega squared. So here's a cool thing. And then r perp is r sine theta. Oh, sick. Okay. So actually, we can just cancel. Yeah, we can cancel the signs, right? Whatever. Cancel. Because I think I just want theta. And look, the m's cancel as well. Goodbye. Okay, cool. So, cosine of theta is equal to 1 over r omega squared. G. Yeah, I was thinking Lagrangian and Hamiltonian. There probably was a way to do it. It would be Hamiltonian. Thanks, Michael. Okay, I think this is it. Let's see if this makes sense, though, right? So, I don't... If omega is really, really fast, then this goes to 0. And cosine of 0 happens at 90 degrees. Which, that makes sense, right? If this thing was spinning super, super fucking fast, this thing should go up to 90 degrees. There's not a nice case on when it goes to 90. But okay. Okay. So theta is equal to the arc cosine of... And actually, wait. I want the height, right? Isn't that what I want? I want the height eventually. Let's just get the height. Is that what they want? Sorry, what do they want? What are the relative equilibrium positions? Relative to what? Oh, but this was the other thing they wanted. Sorry, determine the equation of the relative motion of the ball in the tube. Oh, okay. So this is probably they did actually want some Lagrangian here. I just went straight to like what's the equilibrium position. Oh man. Okay. Let me just get the angle, and then I think I know what it is. Okay. Arc cosine. Yeah, they probably did want me to actually use a Lagrangian here.
The timer is invisible, bro.
I know, it's because it's on the sub goal right now. Once someone follows, that goal will change.
You know what I was thinking?
What's up, dog?
If you switch the new subscriber and new followers, right? And put find out how to put the subscriber name onto the sub goals and the follower names onto the following goals, and see if you can like implement that into the sub and following goals. So instead of having a separate text, it would automatically switch in between.
Oh, I see. Whether it's done a subscriber or follower. Yeah. I could do that. Oh wait, this gets me. Wait, this gets me something undefined. The equation of the equilibrium is trivial. The general equation of motion is trickier. Yeah, I'm seeing that now. Also, I'm getting that there isn't an equilibrium at 4 radians per second. You need r omega squared to be greater than g, right? Because if it's not, then you're trying to take the arc cosine of something that's like greater than 1. But you can't have that. So I don't think there is an equilibrium position for this one. Maybe for 7 there is though. Okay. How would you do it with a Lagrangian for the equations of motion? I'm just curious. Come here, chat. Come here, chat. I know it's like t minus v or something. Right, yeah. MR omega squared. Yeah, that's what we had. Okay, so then what do you say? Gravity is mg. Newton's law along the circular track. Oh, very cool. Yeah, okay. energy's downwards. You have a centrifugal force, m omega squared rho, where rho is r sine theta. I think we wrote that, right? Yep, see? This is rho is r sine theta. Decompose the centrifugal force along the tangential direction. Okay. So they're saying how much of this is in the tangential direction. Okay. So that's like how much is in that direction. So it's that, and then it's cosine theta. Let's see why that is. I assume if this is equal to theta... Oh, then this is also equal to theta. Yes, I do stream. I do stream a lot. Pretty full time, I think. Right? This is tangential. So then this force, cosine theta, gets you the tangential force. Do you see this? This is like the tangential... tangential Fn, I guess, right? So m omega r sine theta cosine theta, which is what we had. You literally have an exam on this on Friday? Yeah, dude. Yeah, you dude. TikTok always knows, bro. Okay, so this is okay. I think we're okay here. Yeah, m r perp omega squared. So, yeah, Fnx is equal to m r omega squared sine theta, and then Fnx tangential is equal to m r omega squared sine theta cosine theta. R perp, yeah. So this is, well, the R perp is r sine theta, so that's why I put that in here. Yeah, okay. There you go. That's how you get that. Yeah, okay. And then what do they do with that? And then they say, oh, gravity is a tangential component too. It does. It does actually, right? So in gravity's case... Oh, I guess we gotta do something like this then, right? Yeah, okay. Dude, look at all the 90s we're having to deal with. Okay, so if this is theta, then this is theta. And so if this is mg, this is now mg sine theta, right? Yeah, there you go. And that's minus. Because this pulls it down. The centrifugal force, which is like the response to the centripetal acceleration, like pulls it up. Okay. So then F gravity tangential is equal to negative mg sine theta. Oh, fucking cool. Uh-huh. And then, okay, tangential force, F tangential, is equal to mass times tangential acceleration, but tangential acceleration is mr alpha, where this is d squared theta dt squared. Okay, so now you have mr theta double dot is equal to this hot garbage minus this hot garbage. This is physics. You have a final on this soon? Okay, cool. Yeah, dude, TikTok knows what's going on. Okay. Good luck on your finals, guys, by the way. Okay, so all the M's go away. Pew. You do XT? What's your question, dude? Tell me. And then, is there a solution for this, which is easy? Okay, so this is just the equation of motion. Yeah, got you. This is... I would say this is more than high school physics. This is college physics for sure. How long have you been gay for? God damn it. Longer than you've been alive, probably, dog. Alright, just divide by R. Theta dot dot is equal to omega squared sine theta cosine theta. minus g over r sine theta. Okay. Nice. Okay, that's the equation of motion. And then, yeah. The requirements we have for equilibrium is that theta double dot needs to be equal to 0. So, yes, good. So, at equilibrium, theta double dot is equal to 0, which I'm pretty sure we're going to get the same answer we already got. That's actually really cool. So if I move this over that 0, I get g over r sine theta equals omega squared sine theta cosine theta. Sine thetas cancel. And so I get that cosine theta is equal to g over r omega squared, which, look, that's the same thing we got here. Very cool. Okay. And that's how you find the equilibrium position. But I don't think it works. Yeah, that's actually really cool. Okay. So, the first one doesn't work, right? Right. Omega is less than that, so there is no equilibrium. Well, the equilibrium is at 0. It's just when it hits the ground. And then at 7, okay, you have 60 degrees and 300 degrees. Right, that's on either side, right? You can either have it 60 or you can have it 60 on the other side. Very, very fucking cool. Yeah, okay, cool. Okay. Does that make sense? FMI Kienko? Right? I forgot actually, yeah, when we divided by this, you have to be careful for the case that theta is equal to 0. Right, so that's why here, okay, you're very welcome, yeah. Good night, man, dude. Equilibrium at theta equals 0. And this one you have equilibrium at the inverse cosine of 9.8 over 0.4. 0.4 times 7 squared. Which, yeah, that's 49. But 0.449 is 9.8. Or no, 19.6, sorry. Yeah. $60 degrees. Yeah. Cool. We did it. Great question. Very cool how you had to, like, figure out all the little angles and stuff going on here, dude. This was kind of a mess.
Well done. Well done.
But yeah, you didn't need a Lagrangian Hamiltonian. You just... that's kind of fun, actually, that you just needed F equals ma, and then A is just whatever. R alpha, and then alpha is theta double dot. Nice. Okay, cool. Good question there. Okay, that solution's gonna get posted in our Discord. So if you are in our Discord, if you're not, go join. Right here in homework help, what'll happen is I will drag in the screenshot into wherever it is. Whoa, where was this question? Yeah, this was his. So we're gonna drag it in. So there's the solution. Now I can go see it. Cool. Yeah, that's satisfying. That's honestly why I like physics. I think physics is super cool. In that it's like a puzzle, but I don't know. It like we did it 2 different ways and we got the same answer, which to me is like I did something right. Balding Connor, what's up, Balding Connor?
Oh yeah.
Okay. Prime gave me this question. What is this question, by the way? What are you asking me with this question? You just submitted this. Prime, you want to tell me what you want me to do with that? He's asking me to factor it? Oh. I don't think you can factor this. What? Oh, that's okay. Yeah, welcome, dude. Yeah, there's cheese in the back. Go grab yourself a Sprite or something. Just hang around, dude. Balding gold, dude. I'm already balding. Like, look at my hair. My hair is slowly losing itself. It's the curse of getting older. I still have my beard though. I like my beard. Okay. Yes, you do have to do this with the quadratic formula because unfortunately nothing multiplies to 4 but adds to 2. Right? Like 1 and 4 doesn't work and nothing works. So you just have to. It doesn't factor. It doesn't, unfortunately. So Dan says wait, never mind. Yeah. Quadratic formula does work. So A equals 1, B equals 2, C equals 4. That's because there's nothing here. So X equals negative. You don't need to. What do you want me to do? He says no. Don't do it.
X plus 1 all squared is x plus x squared plus 2x plus 1, right? So just write that as x plus 1 all squared plus 3 is equal to 0, and you have no real solutions.
Oh, you mean if I wanted to that? Yeah, we could also complete the square. Yeah. That would also work.
Yeah, and you don't have any solutions here.
But couldn't I write like some imaginary factors, right?
Oh yeah, sure. You can do this the same way, yeah.
Yeah. X equals negative b plus or minus square root of b squared minus 4ac all over 2. Oh, where'd that come from? So negative 2 plus or minus the square root of 4 minus 16, which is negative 12. All over 2. So negative 2 plus or minus, what's that? 2 square root of 3? 2i square root of 3 all over 2. So there you go. You get negative 1 plus 2i square root of 3. And then, or negative 1 minus 2i square root of 3. So these are, so your factors are x minus.
I think it's just I, not 2i.
Oh, you're right. Thank you. Yeah, sorry. This cancels as well. Yeah. Thank you.
No problem.
So that would be x plus 1 minus I square root of 3 times x plus 1 plus 1 plus I square root of 3. Thank you, Maya. Yeah.
Good job.
Yeah, Diffie Q, Fourier, yeah, all that stuff. We can do all that. Yeah, cool. All right, great. This is a fun question. Love. Nice. Thank you, Prime.
Well done. Well done.
I equals the square root of negative 1. That is true. All right, come back. All right, let's see. Bruh, what do you got for me? Oh, Jesus. Someone's asking me engineering questions. A 2-stage compression refrigeration system. This is engineering. This is engineering thermo. Yeah, saturated liquid, flash chambers. Oh, Jesus. Yeah, I can't do this. Yeah, no, I can do like basic like physics thermo, but when we start talking about like, I need tables for this, I'm pretty sure. Because they're talking about like saturated liquid and then saturated vapor. There are tables for these things. And then also like refrigerant 134A. I bet that has its own little like thing. Oh, you're just struggling how to approach this problem? Okay.
I think refrigerant 134A is actually a table.
Yeah, it has to be a table. Yeah, it has to be like a variable. Yeah, this is engineering thermo, which I don't know. Okay, but you know who does know? Chat knows. Chat's very good at engineering. Let's learn from chat. I taught this at one point, like years ago, decades ago probably. I remember I had a bunch of people from like Dubai that I was tutoring in this stuff. Yeah, so there you go. See, yeah, you need all these. You need like H1, S1. Okay, so apparently throttling is isenthalpic. Wow, I didn't know that. That's an engineering term. I really struggle to trust chat. Well, I trust it more than me because I had no clue that throttling was isenthalpic. Which means that enthalpy is conserved. So H2 equals H1 equals 247.3. And then, oh man. Engineering is easy in that the math is not too hard. Like, look, does this look like hard math to you? No. This is doing a linear approximation of what H2 is based on HF and HG. It's not very hard math. It's just a bitch because you have to go look up this on the tables. You've never heard about isenthalpic? Yeah. The mass flow, yeah. I mean, some of the stuff looks right. Like M dot QL is big Q, big Q dot. And then, yes, I remember coefficient of performance is Q dot over W dot. What's up, Feminomenon?
My man.
Yeah. If I was an engineer, I could figure this out, but I have not done this. But you know what I'll do? I'll still put it in my Discord. And maybe one of the engineering friends I have will solve it. So, stay tuned. We'll see. Okay. Let's see. Just because I know I can't solve it that quickly. I'd have to learn it.
I think it just lied to your face.
What just lied to my face? What?
ChatGPT.
Maybe it did. I mean, but it seems right to me. I remember kind of doing that, like for refrigerant stuff.
I think the formulas are okay, but like
yeah,
the way it interpreted it wasn't.
Oh, you don't think so? On this one?
No, it's certainly not. Like how can 88% be the answer for part A? Like what?
The fraction of the refrigerant that evaporates? Yeah, I mean that would suck.
Like
you know.
How does 88%?
Maybe it's just a terrible fucking refrigerator.
That makes no sense.
Yeah. Yeah. This is just like it's too specific. It's specific to like refrigerators. Like I don't know anything about refrigerators. I fixed many refrigerators, but I don't know like how they actually work. You're welcome, Javik. All right, you want to do this one, Narosky?
Yeah, sure.
Let's do it. Let's learn some stuff.
This one was actually on my 10th grade.
Your 10th grade thing. Okay. So
Yeah,
function.
national
So
context.
is this complex plane maps to complex plane?
Yeah.
Such that omega f of z
W.
or w. Okay, such that the magnitude of wfz plus is this zfw?
Yeah.
Is equal to 2 times the absolute value of z minus w for all z and omega are in the complex plane. Find all solutions f. okay. Is W's a number? Yeah.
Yeah, W and Z are complex numbers. Yeah. Not strictly imaginary, just complex.
Okay, so we have this. This is what we're saying?
Yeah, this is what we have.
Is equal to 2 as values. You need to memorize the unit circle, Mahad? No, dude, don't memorize it. You only need to know 2 triangles. 2 triangles. All you gotta know is 2 triangles. You can solve it. Go check my TikTok. The very, very bottom. It's one of the first videos I've made. Talks about how to do the unit circle without memorizing. Go do it. Okay. Ryan Bush says product with conjugate.
It's not Z minus W, it's Z times W.
Oh, that's Z times W. Okay.
Yeah.
Or I'm just gonna do this. Okay. Okay. And I need to find all functions f that do this?
Yep.
Ooh.
Yeah. That's what we're trying to find out.
Is equal to 2ZW. Z times W. Oh, so wait. So this needs to go to Z and this needs to go to W. Right?
Kind of.
In order to get WZ plus ZW, which absolute value of that would be 2ZW. Yeah?
What you did right now was giving values for the function, which is not allowed.
Well, I'm going to figure out what the function does.
Yeah.
Wait,
Kind of.
Can f of x just equal x? Can I just say that?
That is a solution, but it's not general. It's not the general solution.
It's not general, dude?
Yeah. If I would tell you where you're going wrong right now, you would have the solution. I'm just going to say that.
Oh, okay. All right, give me a second.
That is a big hint.
If you were to tell me where I'm going wrong on this. The complex thing's kind of interesting. Absolute value too.
Give values for Z.
Can I say f of x equal to negative x? That technically works as well.
That works as well, yes.
Yes. Okay.
So you have found 2 solutions. You only have an infinite amount more.
That's dope. Surprise, motherfucker.
Oh no, dude! Only an infinite number. Find all such functions. Okay.
So it's a general form of these functions.
All right. Oh wait. Okay, so if f of z needs to equal z, that means z is equal to f inverse of z. Maybe? Oh, I'm so close. People say I'm so close. Fuck. Z e to the 2 pi I? Wait, this is 1. Wait, Psychode says if f multiplies z by a but divides omega by a, then you also get it. Oh, okay. Wait. If f multiplies z by a but divides, and wait, z and w are just like whatever, but divides w by a, then you also get it.
So, do you want a hint?
Yes, please.
Do you know? Actually, I'm just gonna say let P of Z and W be the how we're gonna.
Like this?
Like I'm very careful.
Like this?
Yeah, this should be our initial relation, right? So P of ZW is exactly what we're giving. So the absolute value of WF of Z plus Z. So that P of ZW is exactly that statement. This is a statement, P of ZW. It's not. It doesn't mean anything, right?
Okay.
It's a statement. So it's not equal to. So P of ZW is not equal to. It's. I would say.
It implies?
Yeah, that works. No, well, not implies. How do you colon? Colon. I will put a colon. So this is P of ZW. So this is equal to 2ZW.
Yes.
Is equal to 2 absolute value of ZW.
Yeah.
This is a statement, right? This is a statement which we have denoted as P of ZW.
Oh, sorry. It's not Z comma W. It's P of ZW.
No, P of Z comma W.
Okay, cool. All right,
Yeah,
cool.
That's right. Yeah. So this is
All
a
right.
statement. We have made a statement. If we substitute values for Z and W, the statement holds true,
Yes.
right? Because the statement is true for all Z and W complex.
Yeah, I can make it A and B and like whatever.
Yeah. So what happens if we take Z equals to 1 and W equals to 0? So we would have P of 1 and 0.
Mm-hmm. Okay.
Which is 0.
Yes.
So
but this is, wait. This is 0. So this tells me that f of 0 is equal to 0?
exactly.
Okay, what does that tell me?
So what happens if we take W equals to Z?
If W equals Z, then I would get Z f of Z plus Z f of Z is equal to 2Z squared. Oh.
So don't forget the absolute value.
Yes.
This is P of ZZ.
Yeah. Okay. So what? That's 2Z f of Z absolute value equals 2 absolute value of Z squared. So I can just get rid of the 2's, yeah? I can get rid of the 2's for now, right?
Yeah.
Oh shit.
And
Oh
we can divide.
shit.
So
F of Z is equal to the absolute value of
Z.
Absolute value of Z.
Yeah. So absolute value of f of Z is equal to Z.
Wait, so F of Z is just equal to Z? Okay.
Wait, no. No, because we are in the complex plane, right? So we cannot just take out the...
Oh, okay, just take
It's
out.
very important. It's very important we do not get rid
Yes,
of
Paul
the
Cement, I'll do it.
absolute values.
Okay, so wait. So absolute value of F of Z is equal to the absolute value of Z squared divided by the absolute value of Z. Yes?
Which is just the absolute value of Z. Yes.
Okay, so absolute value of F of Z is equal to the absolute value of Z.
Yes. This is what we have figured out.
Okay.
So what we have proven so far is that the absolute value of f of z is equal to the absolute value of z, and f of 0 is equal to 0. This is 2 things we have so far.
Yeah.
Right. For this, we would have gotten 2 points on this question out of 7.
Okay.
So it's good progress.
Not great. But still not terrible.
Not terrible, yes. So what if what if we take P of Z and 1 now?
P of
So
Z and
remember
1. Okay, so P of Z comma 1 is equal to... I can
Is
remember what
not
this
equal to
Sorry, not equal
It
to.
is a statement.
It is equivalent to the statement that.
Yes, indeed.
1 f of z plus z f of 1 is equal to absolute value of z. Thank you. You suck at math. Welcome. I'm slowly getting not as bad at math. Okay, cool. But we said f of z is equal to z.
No, the absolute value of f of z. Right?
Fuck.
But
Okay.
it's close. What we do know is that if by the triangle
CAFG.
inequality, right? What can you do with the triangle inequality?
Ooh, okay, with the triangle inequality, I know that absolute value of f of z plus z f of 1 has to be greater than or equal to absolute value of f of z plus absolute value of z f of 1.
Which is actually the other way around.
Sorry, less than.
Yep.
There we go. That's what I meant to say.
And both sides are equal to the absolute value of 2z. Or actually 2 times the absolute value of z. Do you see why? You forgot a 2 there.
Forgot a 2 here. Oh yeah, there was a 2
yeah,
here.
You forgot a 2. Yeah. Which you can bring up, yeah. And both sides here are actually equal to that. Yeah.
Okay.
Because now you can use what you know. You know that the absolute value of f of z is equal to absolute value of z, right? On
Yes.
the right-hand side. You know the first one is actually equal to that. And
Yeah.
z times the absolute value of 1. Well, we already know that the absolute value of f of 1 is 1.
Yeah.
Yeah?
So this is just absolute value of z again.
Again.
Okay.
Which is what we
expected.
thought before. Yeah.
Right.
Yeah, we expect that. So we have an equality case in the triangle inequality. Do you notice?
Yes.
Yes. So
F
that
of z
actually
plus z f of 1 has to be less than 2z. 2z, right?
yeah, but so then we have an equality case in the triangle inequality. So what happens if we have an equality case for f of z?
Oh, in order for these to be equal, f of z has to be equal to f of 1. Or, wait, no.
So, no, what we know from the triangle inequality, what happens if we have an equality case is that f of z must be equal to a coefficient, let's call it lambda of z, right? Lambda sub z. So it must depend on z.
Mm-hmm.
Times f of 1 times z. Do you know this?
I don't know this.
Hold on, let me pull it up for you real quick.
Nice. Slide John says, what math is this? This is like kind of, I think this is like real analysis. It's like competition math. And then Fetty asks, why do I find linear algebra very hard? It's because they use a lot of weird like terms sometimes, like basis and I don't know, like span and all that stuff. Any tricks? Really just doing a lot of problems for linear algebra for sure. And just getting really comfortable with doing the math. And then learning to think about like columns. Like you have to like see the matrix. It's kind of weird. But the columns like kind of express. Oh man, how do I explain it? I hate using the same word, but it's a basis. It's like a coordinate system. I think seeing everything as a coordinate system helps me with linear algebra. Thanks, Troll Cats. What's up?
I give you a screenshot of what
All right,
the
let me see
equality case should be. Like this is Google explained it a lot better than I could.
Okay. Well, I think you explain things great, Narski. Okay, equality condition for a triangle inequality, a plus b is greater than c occurs when the 3 points form a degenerate triangle, which means they lie on the same straight line, so the triangle has 0 area. Okay. Got you.
Right. So see below it explains what happens for vectors, and that's what we care about.
Okay. I see.
Right? So yeah, they are non-negative scalar multiples. Yeah. So that's what we have to have right here.
Okay.
So our vector v is actually a function which holds, right? That is true. And our vector u is a complex number. Z.
Okay.
Actually, f of 1 times z is
Yes.
the other complex number. Yeah. So there must be a lambda greater or equal to 0 that depends on z.
Such that holds.
F of z. Yeah, exactly.
Okay.
So we have actually found a form, kind of, for f of z. Now we have to kind of turn this into something less
ugly.
less ugly. Exactly. Yeah.
Well, I know f of 1 is equal to 1, right?
Well, you know that the absolute value of f of 1
Absolute value of f1 is equal to 1.
Yeah, it's very important. Don't forget.
Okay.
So that's a very nice next step. So because you made that mistake, what do you think about doing now? Like, you know something about
I want to put absolute values.
You want the absolute values, right? Because you know that lambda is a real number. It must be a real number. So you can pull it out of the absolute value.
Oh, okay. So I could do this is equal to lambda z, and then this is absolute value of f1. Yeah, the complex absolute value, dude. Like, fuck.
Yeah.
Okay. Okay, so like that, yeah?
Yeah, and you can separate those two absolute values. So a product of absolute values is the absolute value of a product.
Yes.
Yes, that is nice. And now you can say that the absolute value of f of 1 is 1. So this...
Aha! Oh my god, dude, all this math stuff is hilarious, dude. Because I was just like, fuck it, it's just 1. It's like, no. You have to like go around here, do this, and now it's 1. And I'm just like, okay, I get it. Okay, so absolute value of f of z is equal to lambda z absolute value of z. Can I now remove the absolute values?
Now, yes, we are at that point. What do you know about the absolute value of f of z? There's one last thing you know about it.
It's equal to z.
It's equal to the absolute value of z.
So lambda z equals 1.
So lambda z equals 1, exactly.
Yeah.
So now we can rewrite it. So what we knew was the absolute value of f of z is equal to...
Is equal to z, absolute value of z.
Yeah. For all z this time. So our conclusion is that f of z must be a number of the form z times, let's say, c, constant for a constant, right? Where c is f of 1, is a complex number of absolute value of 1.
Oh, right? Okay. I see.
Because we knew already that...
Because this is equal to 1.
f of z...
I see.
Look a bit above. Like scroll up for a second. A bit more. So when we had the equality case for the triangle inequality, what did we figure out for f of z? Like zoom in a bit.
The triangle
it's lambda
inequality.
z. It's lambda z times f of 1 times z.
Yes.
See. So if lambda z is equal to 1, then f of z is f of 1 times z. Mm-hmm. And f of 1, let's just call it c because it's a constant.
Right.
Right. So that's the final form.
Okay.
Yeah. So it's z times c.
Nice.
That's 7 points on this question.
7 points. So it's so funny. Yeah, I would have gotten the 2 points. Be like, dude, it's just fucking z, dude.
Actually, no. If you actually like work this out, and suddenly you had like an hour. Let's say you had an hour on this. Like you wouldn't think of the triangle inequality, but you'd find the form.
Dude, the triangle inequality comes up so many times in just like also, especially in competition math for sure.
Yeah, but I honestly don't see it as much now. I don't know why. Like I don't see any inequalities in 11th grade.
I see it a lot because of you. All right, nice, cool, good question. I appreciate you taking me through it. I like learning the rigor. The rigor is important.
Yeah.
All right, let me see. Johnny, you gave me a ton of questions here. I'm not going to do all these. Which one do you want? Johnny. Or you submitted it twice. I don't know how you submitted it twice. The bot shouldn't allow you to submit it twice. And then Paul, I do see your question. Ooh. This one looks fun, Paul. Yeah, dude, I did want to drop that shit ASAP, dude. John says, can you do number 1? Can you do number 9? Yeah, sure. I can do this. Boom. Paul, dude, it looks so much fun. What are you talking about? Aiden, you got a question? Did you submit one? Okay.
How long are you gonna go on for?
I'm gonna do another 30 minutes.
No, 30? Okay,
You should go to bed though. It's late for you.
Yeah.
It's late for you, dude.
Because I woke up like a few hours ago, right?
Oh,
like
okay.
right before the stream. So yes, I'm fine.
Nice. Okay.
Yeah. So I think I'll leave you guys to it.
Okay. Cool. Thanks, Norosky. I really appreciate all the help today. Big round of applause for Norosky for teaching us some math today. I love it. This was great. Nice.
Thank you. Yeah, I'll tune in. When's the next time you're streaming?
Tomorrow. We'll stream tomorrow. And then I think we'll stream next week. But definitely tomorrow.
Okay. Maybe I'll come in tomorrow.
All right, cool. Love it.
See ya.
Enjoy. Okay. Find the volume. So volumes for these types of things, these are kind of nice. You just find what the like the two-dimensional area is, like the area of this, John. And then you just multiply by like how many of those are. So like the thickness of it. So this would be, so for the triangle, right? This would be equal to 1/2 base times height. So that's equal to 1/2. We're going to keep everything in millimeters. 7.2 times 6.5. All right, so you can get that on your calculator. We did prove lambda equals 1. So there we go. 0.5 times 7.2 times 6.5. That gets us 23.4. Right angle definitely helps. Yeah, 100% helps. So once we know that's 23.4, now we just multiply this by 3 to get like how many these are. This is like how many of the cheeses, right? So 23.4 times 3, and then yeah, that's equal to like 70.2, which is answer choice B. Oh, notice how they kind of said height and base here, I guess. That's actually kind of cute. They put HB. I don't know why they put that in there. Does that make sense, Johnny? Where that comes from? Why? I think I can do another one of yours. This wasn't actually too bad. And that's volume. Okay. Surface area is a little tougher. Here, let's just speed run these. I can speed run these real quick for you. So we only have 3 more questions. Okay. Also, all the numbers are pretty far from each other, I feel like, which is like not bad. Or they're kind of far from each other. Okay. Surface area. So this, you have to do the surface of this, which is 5 by 17. So that's equal to 85, right? That's for this part. Then you need the area of the trapezoids. Area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. And they tell you the height. The height is this 90-degree thing here. They say is 8.4. So that's going to be 1/2. This is also like the average of the bases. So the average of 17 and 6. Because see how you're adding them up and then dividing by 2? So that's 11.5. Or 1/2 of 23, I guess. Yeah, fine. And then times 8.4. So that's 11.5 times 8.4. What do we want to call that? 88. Plus 4 is 92. Plus another 4. I'm going to call this 96-ish. Okay. But then that's also times 2. Because you have 1 here and you have 1 on the other side. So that's 192. And then you have the top part, which was a 6 by 5, right? So this is 5, this is 5. So that's 30. So whatever. This part is 30. This part right here was this. And then you got these two parts, which are 10 by 5. So that's 50. So these parts right here. This is 10 this way, but 5 this way. So that's 50. And then 50 is 100. Okay. So you have 100 plus 85 plus 192 plus 30. What's that? 292. 332. I don't know what P is. The perimeter, maybe? I have no clue what P is. 332 plus 85 is about 417. So I'm assuming it's this one. P is perimeter. Interesting, they're making you... I don't know why you need the perimeter. Perimeter? I mean, the perimeter of the whole thing is huge. What? How do you have the perimeter of a 3D shape? Perimeter is infinite. Or maybe there's another equation you're supposed to use. This one's fun. So you have a 23 by 14, right, from here, but then you got 2 of those. You have an 8 by 14. You got 2 of those. And then the last one you have is plus a 23 by 8. And that's also times 2. So you have pairs, right? You do this number with this number times 2, this times this times 2, and then this times 2. Because then that gets you this amount. Let's see if we just guess this real quick. 8 times 40, 80. Or what is that? 16. This is it's like 220-ish, I guess. 46 times 8. I'll say 50 times 8. It's like 400. And then that's like 30 times 20. It's like 600. I think it's this. I think it's C. Someone tell me if I'm actually correct. And then this one. Ooh. I want to say a square pyramid is 1/3 base times height. Is that right? Or like rectangular perimeter formula. Oh, sorry, rectangular volume. Prism. Rectangular pyramid volume. Yeah. Oh, it's length times width times height divided by 3. That's actually really cool. Ha! Sorry. It was length times width times height. Okay. So that's 7.5 times 11 times 24 all over 3. 24 over 3 is 8. 8 times 11 is 88. 88 times 7, like 560-ish. Oh, dude, these guys are fuckers.
Huh?
Ugh. I actually have to calculate this. Damn. So close. They made the numbers too close to each other. 8 times 11 times 7.5. Wait. 8 times 11 times 7.5. 660. And that's it. Nice. Good job. right, Johnny. I hope that made some sense. I will drop this screenshot in our Discord for you. So if you come here to our Discord, you should see your question get posted here in the homework help. No, I'm glad I helped you, Slide John. There you go. There's your screenshot. And SARS. Cool. Alright, let's see. What do we got left? Athena! Oh, Jesus. Find the first 4 non-zero terms in a power series expansion about x equals 0 for the general solution to the given differential equation. Okay. Oh, this is like ODE stuff. Oh dear.
Disqualified.
Which one of my friends here knows ODEs? I know one of you guys knows ODEs. What's up? Alistair, do you actually know ODEs? Maybe. Okay, fine. You can come speak.
I'm not gonna tell AFG. I'm not gonna tell AFG that I actually managed to speak. I don't want him getting jealous or something.
What? Who's getting jealous?
Potentially AFG, since he like tried to speak earlier alongside me.
Oh, I'm
yeah,
sorry.
but,
Oh, yeah. No,
anyway,
you're good.
what are we doing here? Anyway, what are we doing here? Oh shit! What the fuck is? What the frick?
I asked if you knew how to do this. Alistair, I asked if you know how to do this.
But yeah, I'll try. I'll give it a shot. I mean, if we're talking ODs, I'm trying to give it.
Simplify and re-index. Solve for the biggest.
But when
Sorry,
it really comes to summation, right? I guess I'll learn something. I guess I'll learn a thing or two.
Oh, I see. This is the differential equation. It's this. Find at least the first 4 non-zero terms in a power series expansion by x equals 0 for a general solution to the following equation. Y prime plus x plus 2 times y is equal to 0. So
maybe
this is
we can move all the y terms to the left side and then just integrate. That's actually quite easy.
No, but they want to do it as a power series. So
oh shoot.
Y is a to the n xn. Y prime is the derivative. Derivative of a power series is this comes out, this comes down, this drops by 1, and then you re-index up by 1. Okay, cool. And then x minus 2. Okay. So then you expand it out. Minus 2. You put the x in there. You simplify. X to the n becomes x to the n plus 1. Yes, I agree with this so far.
Oh shoot.
And then you re-index, right? Okay, okay. So if everything starts at 0... alright, then this is n plus 1, a n plus 1, x to the n. Oh, very cool. Wait. And then this is... Wait a minute. Wait. How are you having them all start at 0, though? I agree with this one. Where did this come from? Because it was n equals 0. This should be an, no? For loops are based.
Yeah, when taking derivative, the index changes, but integration.
Yeah, I agree. The integrand. Yeah, I know the integrand does this. I'm saying for the simplifying re-index case here. You brought this in, so this is x to the n plus 1. I understand that you can re-index this to 0 by let me think how you do this. Sorry. The sum from n equals 1 is the same thing as the sum from n equals 0. Good, yes. Of n plus 1, a n plus 1, x to the n minus 1 plus 1. Isabella says the last one, you just make it equal to x to the n, and then you can just make it equal to 0. I'm okay with this. No, I understand this. This is the one I don't like. I don't like this. Yeah, it's x to the n plus 1, you're right. But this needs to start at n equals 0. So wouldn't this still need to be an? I understand here why the n's change, because you're changing your starting index, but the starting index is the same here, right? It's the same, n equals 0. So how are you just redefining things? Decrease and increase, or decrease and increase and decrease, is it not? Yeah. But what about the index? Yeah, you have to move the index if you're going to move this. Because, I mean, basically what you're saying is... Okay, here we go. Dojo says a0x plus a1x squared. Alright, thanks, Blake. Okay, as long as we just get it to x to the n form, we can just fucking change it to start at 0. Sure. Okay, fine. Okay. I was like, wait, what? I get it. Okay, fine, sure. Okay. I got it. You're saying this is n plus 1 minus 1. So then this is n minus 1. So then this is a n minus 1. This is a minus 1 x to the n. But this should be from... This should be from... This should be from... Wait, 1 sec. Isn't that like n minus 1 equals 0? And then, yo, it's from n equals 1, no? And then you're just re-indexing it to 0? What happened to the a0 term? Okay, whatever. I'll trust that you're allowed to do this. Solve for the biggest term. Well, first of all, do we know this is right? Here. Just took my Calc 2 final on this. Yeah, dude, the algorithm always knows exactly what's going on. Here. Yes. Oh, you're okay, Isabella. You want to join our Discord and come talk? You can come talk here in the Discord if you want to come talk in the VC. Yeah, let's see. I just want to see. I want to see what chat does.
You mean ChatGPT?
Yeah, I just want to see what it does.
Oh, okay.
Okay. Oh, you didn't even know. If anyone ever wants to know what the question is, if you go to the website, actualofficehours.com, and you click on the queue, and then you click on this person's username, the first question comes up. Okay, Alistair, I'm going to put you back in the audience. Alright. ChatGPT does seem to agree with Isabella. Yeah. I agree it does. Chat got here, which I agree with. Right, I agree with this. I'm totally valid with this. I like this. I like this. Wait. It doesn't have a minus though. We had a plus. It had a minus. How can that be? Did we screw up? Oh, yep. Okay, first little mistake here, Athena. This is a +2. Gotta make this plus. It's okay. Okay, now that's okay. What's up, Isabel? Is your mic working? Can't hear you yet. I'll let you know when I can. Just keep trying. 2an, right? And then this is what I agreed with. That if you wanted this one to be x to the k, this would have to be n minus 1, right? Because you're doing n plus 1 minus 1. This is n minus 1. So this is n minus 1 equals 0. So that goes from n equals 1. Yeah, why can't I hear you? I have your mic all the way up. Okay. So then that's what this was. This is my grievance I have. But then what does chat say? Chat says for k equals 0, compute the last two sums by adjusting. Okay, try again. There you go. I hear you, Isabella.
Good
Okay,
job.
Perfect.
So, basically, okay. The first step, what I did was, oh yeah, it is a +2. That's right.
All good. I agreed with you. It was just here I was like starting to like kind of get a little confused. I think they wrote out what like the n equals 0 state would be. And so they said, okay, well when n equals, because now this starts at 1. One sec, let me see how this works. Sorry. Oh, are they doing for the whole thing? Oh, okay. Wait. For n equals 0, where is this k plus 1 coming from? What the hell? Oh.
Let me try to explain it as best as I can because I think
Please.
I maybe made a few arithmetic mistakes. But okay, first thing I did was I did y equals like just the regular definition.
Yes.
I
The
plugged
derivative's
into
fine.
the ODE.
Yes.
And then I distributed everything. I fixed it to a +2 on my
I love
end.
that. It's great.
And then so you distribute the x, you get
n plus 1, right, from the exponent.
Exactly, x to the n plus 1. And then I want everything to be like re-indexed, so then we just get an x to the n. And so what I did was for the first one, I did what did I do? Oh yeah, I made everything.
You say like n is
an
equal to
x
like
plus
k
1.
plus 1 or something, right?
Yeah, so that's exactly what I did. I did everything like n plus 1, and then I got everything in x to the n. And my professor, he said, as long as we have it in x to the n, I can just change everything to like start at 0, like the index to start at 0, which is a little weird because I wasn't used to that in Calc 2.
That seems violent. I'm like, wait, what?
He just said like as long as we have everything in x to the n, like just change it to 0, like our index to 0, because once you start plugging things in, like it'll make sense why it's just going to be the same thing. But so I got the first one to x to the n by doing like n plus 1 times a to the n plus 1. And then so for the second one, I needed it to be like x to the thing. I needed to be to like x to the n again. So I did -1, and then my summation would go from n equals -1 to infinity. And then that would change everything to a to the n minus 1. And then since it's just at x to the n, again, I just changed it to 0. And then the last one was already in like x to the n, so I just left it as a sub n. Yeah,
this one's great. I'm cool with this one for sure. Yeah. And I think they are too, as well. They like this. This is fine. This is fine. This is the one we were kind of debating about, right? Because that's where I think this should still start at 1. If you're gonna this middle one right here, which is the last one in ChatGPT. I think that one should still start at 1.
That's what I thought as well, but
your professor says that just because I
explained
have this and this and this, I can just reindex this to 0.
like my professor explained it in such a weird way. I think I might be getting confused, but he told me that pretty much as long as I get everything like into x to the n, I can just reindex everything like to 0. But then that confused me because when I was actually like solving for it, everything kind of got messed up.
Yeah.
Which is why I got stuck, because then you have to like plug in like n equals 0, n equals 1, n equals 2 to find the non-zero terms. And that's where I got stuck, because I was getting a to the -1 and I was just like, it's not like as
it's not simplifying.
or a sub 1. So I like, that's where I kind of got lost. So do you think I should keep it at k equals 1?
I think you should change. Yes, I think you should keep it at k equals 1 and keep it separate. Okay. And then I'm just looking at what chat does. Chat says, okay, well, let's try n equals 0. Let's try n equals 1 and see what we get. So when you do n equals 0, right, you're not even looking at this term, right? You're just looking at these two. And so that gets you the n plus 1, a to the n, a to the n plus 1, right? A to the n plus 1. And then that's x to the 0, which is just 1. And then you have plus 2an, x to the 0, whatever, cool. So that equals 0. Or sorry, 2a0. So this was a... Wait. Yeah, wait, one second. Yes, okay. This is an, right? Equal to 0. So this is n plus 1, a1 plus 2 a0 is equal to 0. And then, if n is 0, okay, then that just gives me a1 plus 2a0 is equal to 0.
Yeah, chat got that, and I was really confused how I get it now.
You just have to treat this one separate from the other two that you're grouping.
Okay, and then that makes sense.
Okay.
Thank you so much.
All right. Is that all of it? Does that solve it? Like, I think there's more to it. No. I can solve the rest of it.
A few of them, but yeah, it's pretty much done already.
Okay, cool. Yeah, tell your professor, like, no. You can't just like re-index that. Like, you lose the constant. Yeah.
Thank you. I appreciate it.
You're very welcome as well. Thanks for the question. Thanks. Wow. There we go. See, professors make mistakes sometimes. They really do. Okay. I'll add more time to the clock. I can tutor for another like 15 minutes, and then I actually need to go. So let me add more time for you guys. I had a student like push back, so there you go. You get another 15 minutes. Which branch of math has the most memory? What do you mean the most memory? I don't know what most memory means. All right, Carlos, Paul, don't worry. I'm going to get to both your questions, Carlos and Paul. We're going to do it. Even though I know one of them was like a really ugly integral. Really ugly. Oh, you got to memorize the most amount of stuff? Ooh. Probably any like thing that's proof based. You gotta memorize a bunch of proofs. I've done combinatorics. I don't know if I've taken a formal class on it. I mean, I guess probability is kind of a combinatoric class. Okay, nice. What do you want me to... Okay, Carlos, what do you want me to answer here, by the way? What's the question? Do we want these two equal to each other? Is that kind of it? Is there a solution to this? So, I forget how this works. Is this just like x to the 4th? Oh, find the area of the integral. Ooh. Oh, like, okay. Well, I gotta figure out where they intersect though, right? Okay. So yeah, first thing is find intersection points, Carlos, right? So 2 minus the square root of x is going to look like this. And then x to the fourth is going to look something like this. So I need to solve for one of them where it's 2 minus x. And then solve for the other one where it's 2 plus x, if that makes sense. Right, I got to find these whatever these intersection points are. So I'm going to say x to the fourth is equal to 2 minus x. Or x to the fourth is equal to 2 plus x. Kind of ugly. X to the fourth plus x equals 2. X to the fourth minus x equals 2. I don't fucking know. Can I just use Desmos to find this intersection point? I really don't know what it is.
How's the stream going?
What's up, dude?
It's been like forever.
Yeah, I got like, yeah, we've been going a little bit longer. Yeah, 3.5 hours today. We're gonna go 3:45. Yeah.
Damn.
That's dope.
I remember it used to always be 1 hour teaching, then 1 hour.
Right, and then we
gaming.
played an hour of gaming. Yeah, right. Yeah, then quickly I started getting like way too many questions getting asked.
Yeah, way too many. Now it's like we only get 1 day of playing, and I think we only play for like 2-3 hours.
Yeah, I know. Life. There we go. There's my intersection points. I'm just gonna pretend I have them. I don't know how to solve that analytically. Second calc. Yes, that's what I'm doing. So I'm finding where they equal each other by using a calculator, because I'm just running out of time to be able to figure out exactly where it is. Oh, it's at 1. Duh. No. Oh, fucking stupid. Okay, thank you. Yes, 1 to the fourth equals 2 minus 1. That is true. And then I bet -1 to the fourth is equal to 2 plus. Wait, what was it? Was the other one -1? We think. Yeah, it's gotta be -1, right? -1 to the fourth. Oh. How is that gonna work actually though? Okay. Anyways, intersection points. All right. Even functions, buddy.
You done messed up,
I messed up. Okay. So that's at x equals 1 and x equals -1. Okay. Cool so far. Also, this is going to be a piecewise function, right? Do you see how, like, it's one function here and then it's another function here? And it's obviously the top function. So we're going to do the integral from -1 to 0 of the top function. So this function is 2 plus x. Here, let me like draw it separately for you real quick. And then I think it actually does something like this. You got a calc test tomorrow. Uh-oh. Good luck, Paul. All right, this is at -1. This is at +1. But then the border's at 0. So this is 2 plus x. And then this one here is 2 minus x. I think. Yeah? Okay. So the first integral is, and again, it's top minus bottom. So that's going to be 2 plus x minus x to the fourth dx. And then we're going to do the integral for the next half, which is going to be from 0 to +1. And that's going to be 2 minus x minus x to the fourth dx. Good so far, Carlos? I guess you could kind of figure out that this intersection is at 1 and -1 by inspection, which is like kind of just to guess some numbers, but otherwise graphing calculator works too. Again, even functions, so yes, so Dojo's right. Because this is symmetric and even, I technically only need to calculate one of them. And then just double it. Yeah. Okay, anyways, so this is 2x plus x squared over 2 minus x to the 5th over 5, evaluated from -1 to 0. So the 0, 1 goes away. And so this is going to be -2 plus 1/2. Or then it's minus, right? So it's this minus this. So it's minus -2 plus 1/2 plus 1/5. Okay, cool. So what is that? 2/10 and 5/10 is 7/10. So -2 plus 7/10. Okay, so it's equal to 1.3 times 2. 2.6. He drew x to the 4th under the axis. I'm sorry. There you go. Are you guys happy now? Okay. And then just double it. Cool. Makes sense? Yep. Nice. Cool. I was, and then I got a couple more questions. Last one. Paul, you're last. I'm ending after this next question. Because I really have to go after this. I gave you guys an extra hour. Extra 45 minutes. Well. But okay. Cool. Last one, and it's gonna be a heater from Paul. Wait, what did you submit to me, Legendary? Oh, more chemistry? Oh, you know, the chem gods in my server will love this. So, yes. You're very welcome. Very welcome, Paul. Let's have some fun. Let's have some fun with this. Okay. Wait, I lost my pen. Fuck. There it is. R squared everywhere. Yes. Okay. Yeah, in spherical coordinates, x squared plus y squared plus r squared, or plus z squared, is equal to r squared. We agree with this, right? So this is really e the negative r squared over r dv, but then this is the tricky part. E is the region bounded by the spheres. Oh, okay. This is easy. So you're just going to go from r equals 1 to r equals 3. dv is dickish, but no, that's fine. Right? Yeah. Oh, we ran out of time on the music. Sorry. There we go. Does this make sense? If we're bounded by the spheres, radius 1 and radius 9, then when I do my spherical integral, which dv in this case is going to be r squared sine phi dr d theta d phi, right? The only thing that's going to change is that r is going to go from 1 to 3. Exactly, right? Yeah. So actually, I don't care about that. So we could do the dr integral last, right? Let's just do the dr integral last. Okay, so then it's this from 1 to 3, Paul, for dr, and then d phi. I always forget which one this is. I think this is 0 to pi, 0 to 2 pi, and then this is e the minus r squared over r. Oh, this is beautiful, actually. Look at this. Okay, I forget what, I know this integral pulls out a 2 pi. What does the phi one pull out again? Sine phi d phi. What does that one pull out? Is it just a 1? Is it a 2? I think it's a 2. Because then you need 4/3 pi, right? Pi r cubed. Yeah. Yeah. Okay. Do these two integrals. You get 4 pi. Integral from 1 to 3. This becomes e to the negative r squared r dr. And then this is a nice u sub question here, right? Because look, r squared, and then I have the derivative of that basically down here. I say u is equal to negative r squared. Du is equal to negative 2r dr. So du divided by negative 2 is equal to my r dr. So now I just have the integral of e to the u over negative 2. Integral of that is just e to the u. So you just get negative 1/2 e to the u. And then u is negative r squared. And then that's evaluated from 1 to 3. The old RDR joke, and you weren't even RDR? Is it? Wait, what's the joke? Okay. 4 pi. Put a 2 there. Put a negative. And then it's e to the negative 9 minus e to the negative 1. Hardy har har RD RDR. Okay. Okay. So then this is just 2 pi 1 over e to the 9th minus 1 over e. I think that's it. Yeah? Look good? Not too bad. The e to the 9 and e to the minus 1 to switch, but yes, very good. Okay, awesome. Oh, right, because there's a negative. Right, because there's a negative, sorry. Right, negative goes the other way. There you go. Yes, that is correct. Good. Awesome. Throw out the negative. Sweet, Paul. Not too bad. Good luck on all y'all's finals that are coming up. We'll still have another stream tomorrow, by the way. So, feel free to come by, get some help. So, Paul. What's secant of x? 1 over the cosine of x, right? Nice. Okay, cool. All right, that's it. I gotta go. Let's end the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Really appreciate all the questions. Again, good luck with all your finals and everything. If you just found us today, make sure you go to the website actualofficehours.com. Join our Discord. That's where I post all the questions. So even if I didn't get to your question today, which is only legendary today, because we went an extra 45 minutes, it'll be in the Discord, and I'm sure one of the chemistry people would love to help out. So yes, awesome. Take care. Enjoy. If you want more help, we're on tomorrow. Click that button. Streaming schedule. You will see we have a stream tomorrow starting at 4 p.m. So come on by. We'll help you out. Make sure you finish the year strong, and then you can enjoy the holidays without being scared of your grades. Okay, we're going to go raid another channel. So if you're following us on Twitch, which is the best platform to go watch us on, go find us on Twitch too. If you found us on TikTok, there's a link there in the website. Go follow us on Twitch. We're going to go say hi to another one of our friends who's on that I haven't rated in a while. I feel like I've rated almost everyone these days. Chilling, cozy vibes. Who are these people sometimes? Okay, we'll just say hi to Science. Science is great. Okay, cool. Go say hi to Science. He's an awesome science streamer. We like him. All right. Enjoy the rest of your Wednesday. We will see you on Thursday. Peace.
Mr. the Geek, GG's, you wonderful soul, on winning a pin number 2. You got it. That will go with your Amber. That'll go with your Amber. Actual education. Bring your bug guy friend. No. That's cool, Zach. Welcome on in Actual Education Raiders.